picture of you in my pocket, and last night I almost lost it. I used to think I should quit you, but I'm so addicted, it hurts. Remember the nights that we would stack the lights by the train tracks, and you would always listen to dashboard. That was the first time that I realized all the pieces of you fit perfectly in the hole inside my heart. And I'd be lying if I tried telling you that you're not everything I want. 'Cause I tried running away, but I can't run back today. Just hoping that you'd let me say I'm sorry. 'Cause all the pieces of you fit perfectly in the hole inside my heart, inside my heart. I wasn't ready for this, looking in hindsight. It's like bringing a knife to a gunfight, and sometimes I listen to your voicemails, need something to fill the void. Remember the night we almost got in a fight in your driveway, and you told me that you needed space. That was the last time that I realized all the pieces of you fit perfectly in the hole inside my heart. And I'd be lying if I tried telling you that you're not everything I want. 'Cause I tried running away, but I can't run back today. Just hoping that you'd let me say I'm sorry. 'Cause all the pieces of you fit perfectly in the hole inside my heart, inside my heart. Remember the nights that we would stack the lights by the train tracks, and you would always listen to dashboard. That was the first time that I realized all the pieces of you fit perfectly in the hole inside my heart.
Sometimes I just can't take it. Sometimes I just can't take it, and it isn't alright. I'm not gonna make it, and I think my shoes untied. I'm like a broken record. I'm like a broken record, and I'm not playing right. Just cynical, how about you kill me till you tell me on the heavenly phone. So hold tight, come on, come on. Oh, come on, come on. Don't let go. Hold tight, hold tight. It's alright, you said. I got my hands up shaking just to let you know that you've got a higher power. Got me singing every second, dancing every hour. Oh yeah, you've got a higher power, and she really someone I wanna know. This boy is electric. This boy is electric, and you're sparkling like the universe connected. And I'm buzzing night after night after night. This joy is electric. This joy is electric, and you're circuiting through. I'm so happy that I'm alive. Happy I'm alive at the same time as you. 'Cause you've got a higher power. Got me singing every second, dancing every hour. Oh yeah, you've got a higher power, and you're really someone I wanna know. You got a high, you got a high. you know now you've got a higher power. You got me singing every second, dancing every hour. Oh yeah, you've got a higher power. You once in any lifetime. I'm going a million miles an hour. When for so long I've been down on my knees in your love song. Take me over and over. For so long I've been down on my knees to your love song. Floats me
She got a big ego, you could see it on a telescope. I'm the same way, it's why we always argue back and forth. I swear she my poison, at the same time my antidote. She the noose around my neck, I couldn't ask for a better rope. Hey. You're like a time bomb, take it away. 30 seconds till you blow up, right in my face. I can't find one good reason to stay. So why do I wait and walk it away? You got me paralyzed. Go away, baby, take my life. 'Cause I don't wanna live if I'm living without you. Suicide love, take me out if you have to. You got me paralyzed. See a dime, keep her in my pocket like some loose change. Drove swerving on the 101 back to your place. One wrong turn, fantasize about the great escape. Hands off the wheel, close my eyes, let me meditate. You're like a time bomb, take it away. 30 seconds till you blow up, right in my face. I can't find one good reason to stay. So why do I wait and walk it away? You got me paralyzed. Go away, baby, take my life. 'Cause I don't wanna live if I'm living without you. Suicide love, take me out if you have to. You got me paralyzed. You left your cupcake on my nightstand. Your favorite necklace is my right hand. Yeah, you were never a part of the plan, and it was over before it began. You got me paralyzed. Go away, baby, take my life. 'Cause I don't wanna live if I'm living without you. Suicide love, take me out if you have to. You got me I don't care if it hurts. I'll pay my weight in blood to feel my nerves wake up. So love me now or let me go. Let me feel these highs and lows before the doors to my heart close. Touch me, someone. I'm too young to feel so numb, 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 numb. You could be the one to make me feel something, something. Make me feel something, something. Show me that you're human. Make me feel something, something. I gave those years away and lost my sense of taste. 'Cause all of your lovers eventually fade and leave you alone in the bed you made, and all of the colors that bleed to gray will mean nothing. Touch me, someone. I'm too young to feel so numb, 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 numb. So give me just enough to make me feel something, something. Make me feel something, something. Show me that you're human. Oh. Make me feel something, something. So if you're gonna stay, then stay. But if you're gonna go, make sure that you heard me just enough to make me feel something, something. Make me feel something, something. Show me that I'm human. Make me feel something, something.
Hey everyone, thanks for coming to Dev Day, Cyber Dev Day. Really happy that you're here. I'm really happy that you spread out, right? Like I used to be a college professor, and the urge to sit in the very back is very high. So thank you for coming. I think you're going to learn. I don't think you're going to learn. I think you're going to. I know you're going to come away with a lot from today. I'm taking, what's your name? I'm taking him everywhere with me. Jonathan goes everywhere with me now. This is going to be perfect. Right, yeah, we're going to talk. If you came to our talk yesterday, or if you're walking on the show floor, what you're going to learn and really have hands-on experience with is that, right? It is our event-driven RAG. We called it Agent Morpheus in the talk. It's Agent Morpheus on the floor. And we've had a lot of questions about, like, can I get this? Can I, where can I download this? And the answer is you can't do that yet. But as a stopgap, and hopefully as of interest to all of you as developers and technologists, we're going to show you how we built it, right? And you're going to be able to get hands-on with code and all that great kind of stuff. And the even better news is you have two people, Rachel Allen and Michael Demerit, that are they represent both of the tech lead sides for Morpheus and cybersecurity at NVIDIA, right? So Michael is the lead architect of Morpheus. Rachel Allen is our lead data scientist. Together, they built this out, right? So all of the great work that you've seen on the demo floor, all the work that you saw on, if you came to the talk yesterday, is them, and they have a whole team of people behind them, right? So I'm going to get out of the way, and we're going to turn it over to Rachel. We have people circulating, and if you have trouble, that kind of things with, nothing's going to go wrong. But in the odd instance that something would go wrong, we'll have people, we'll try to get you caught back up, right? So just raise your hand or yell at us or throw something on us. We'll have people to help you out, right? So Rachel, please.
Ooh. Thanks, Bartley. Good morning. Thanks, everyone, for coming out so early. We're going to start with a little housekeeping, and then I'll tell you what else we'll do after that. So everyone, I think, has the codes, strips of paper, to help you log in and get started. And you should be, hopefully at this point, logging in to the DLI, so that you can all have access to your own T4 instance that we're providing for you this morning. And so if everyone is hopefully at this point or farther along where they have everything spun up, we're good. If you're having any trouble at all, we have amazing TAs around the room, so just feel free to raise your hand. These instances sometimes take like 5 minutes to spin up, so that's why I wanted to make sure everyone's getting started with this right now while we do the slides. I think there's someone in the front. Can we have a TA help out in the front? Thanks, Pete. Great. Yeah, there's some tips and tricks. Sometimes using an incognito browser might be necessary to get started. Great. Okay, awesome. So now that we have that taken care of, I'll tell you about the rest of your day. We'll all be spending a wonderful 4 hours together, but we've broken up the day a little bit. So this morning we're going to do, obviously, the lab setup, which A+ for almost everyone. And then we'll do kind of an overview for cybersecurity trends, and we'll do the hands-on lab. And this will take us about 90 minutes, and then we'll give everyone a 15-minute break. Obviously, you're free to still play around in the lab. Your instances will stay up. And then we'll come back and do another 30 minutes to kind of wrap up the hands-on part of the lab. And then we have Joel from CrowdStrike. He's going to give a presentation about how they're actually using Morpheus at CrowdStrike and how you all can also use the Morpheus platform via CrowdStrike. So that'll be a really great talk later this morning, probably for about an hour. And then we'll kind of wrap it up at the end with a little Q&A, and maybe kind of, I think the main interest of a lot of you is, Gen AI needs to be everywhere, and we're all like very thirsty for ideas. of how to apply that to cybersecurity. So we're gonna kind of spend the last 30 minutes of the day telling you kind of what we're thinking about in other areas. I think one of the privileges of working at NVIDIA is that we just want to give you all the great ideas, and you go out and build them on GPUs, and we're happy. So hopefully at the end of the day, we can have like some good Q&A and brainstorming. Great. So I'm Rachel. I started my career as a neuroscientist, and then I was in academia for a while, and then got an adult job, and I ended up doing data science for an advanced threat hunt team. So I was embedded with advanced threat hunt team for the government for many years, and then moved over to NVIDIA, and so I've been working with our internal teams. I think it's really great, you know, there's few people that have like the data science experience and the cyber experience. I don't claim to have all the cyber experience, but I've been very privileged to be working very closely with a lot of subject matter experts. And I don't know, Mike, do you want me to? And there's Mike Demeret. He is the lead engineer for Morpheus. So I kind of do the use cases, and Michael builds all the accelerated pipelines to support them. He has a physics undergrad degree. What else do I want to say about Michael? He's amazing, and he can spin up anything from anywhere at any time. It's incredible. Let's see. So I'm sure you've seen maybe this slide before. We talk about how cybersecurity is a data problem, but it's really a data problem and a human problem, right? There's too much data, it's coming too fast, there's too many different types. But there's also a staffing shortage, and the attack surface is, you know, growing infinitely, and the number of analysts that we have to look at all the alerts that we're generating from these new attack surfaces, they don't scale, right? So Morpheus and some of the things we're going to show you today, we're tackling both sides of this problem, right? So we have the accelerated pipeline so that you can ingest and examine more of your data. And then we're also going to build a use case today that's going to accelerate your analysts. So we want to see more data, we want to have more coverage, and we also want to kind of force multiply the workforce that we have right now. So I talked a little bit about this, like how do we force multiply a cyber analyst? Like I said, I've been embedded with these folks a lot, and I think, you know, level one, like a SOC analyst, kind of their workflow involves just a bombardment of alerts, right? They have huge attack surfaces that they're trying to monitor. You know, they have alerts coming from lots of different services or appliances, things that they're paying for. And then they also probably have like a data science team that's building something quirky, and they have like those alerts too, and they want, and the data scientists want them to look at those too. So we're part of the problem, we're also part of the solution. And so the workflow for this analyst, right, if you have an alert come in, is you need to gather a lot of context about the alert. What sort of data enrichment, right? If it's an IP address, what other information do I have about it? And so this workflow involves pulling information from the web, from internal enterprise data sources. You know, we have playbooks, we have vulnerability scans, and they take all of this, they collect all this information. You know, you could have 10 browser tabs open along with, you know, your SIM, and they have to comprehend all that information, synthesize it, and then make some sort of conclusion about whether or not this alert warrants spinning up an incident response, or if this is maybe just a false positive, it's just noise. And so this is, when looking at this process of a single analyst, I think, we're all here in 2024, and this makes sense that maybe this is a great use case for an LLM and for RAG. So if you were at Bartley's talk yesterday, he talked about how he got bullied into naming something Agent Morpheus. But we're in charge today, and I love precise names. And so we're doing the CVE exploitability and vulnerability analysis tool today, also AKA Morpheus, or AKA Agent Morpheus. So you might have seen this slide from Bartley's talk yesterday, where we're talking about using LLM's Agent Morpheus RAG pipeline to accelerate the analyst workflow specifically for vulnerability analysis. So I think some lessons learned is that the more specific your use case is, the easier it is to get started, right? So we're not looking to immediately replace or amplify the whole job of a SOC analyst, right? So we picked an issue that we have internally where we publish containers on NGC to share with you all. And we don't want any high or critical vulnerabilities in these containers that we're publishing externally, right? And so our process is we have an anchor vulnerability scan that will scan the containers and output a list of all the CVEs that are present in that container. And then it's up to the team to patch, right? We want to be secure. We want to, if there's a patch available, we're gonna patch first. But what usually happens, and I don't know, maybe some of you see this in your lives too, is that there's circumstances and reasons you might not be able to patch immediately, right? And sometimes some of these critical CVEs are present in your container, and you need to know, do I need to drop everything, stop release, and find a way to patch this and get out of dependency hell and hope everything works out? Or does it not really apply to my container or my environment? Is there a justification where I don't need to do my patch immediately? And there's actually, just last year or 2 years ago, they tried to make a VEX document. So it's a standardized format for if you want to publish something, you're going to use, it's a JSON file that tells you the justification. So now we're using drop-down categories for why you might not be patching in your container. And so this was so perfect for machine learning, right? We're taking this human output and we're actually have categories for reasoning. So we wanted to target this specific vulnerability and exploitability analysis, specifically from containers. And just like I described, we have Agent Morpheus in the middle, receiving all of this extra contextual information. It kicks off with the container security scan, like I was describing. So this putting oops, oh no. Sorry. That's not the right slide at all. So as I was saying, we want to, hey Mike, can you come over? I don't know why this is here. Where's the rest of the deck?
Do you have the live version somewhere? Can you go back to the open recent?
Sorry. Sorry. Yeah. Yeah, we'll share a PDF of the slides for you in the correct order, too. Sorry about that. Okay, great. So not jumping ahead to prompt tuning. Wanted to show you the full diagram of this workflow that we built. This is what we use internally. And this is what's demoed on the floor at the booth. So you're going to want to read this diagram. Starting in the bottom right, you have their build container in your security scan. And then we're going to take this security scan results, and let's say we have a CVE, a critical CVE, And the question is, every CVE is different, right? It's a free-form text. A CVE description is not a standardized format. They try to include, version numbers and patching, and there's information that folks are asked to include in that description, but it doesn't follow a standard format. And there's also different sources of information about CVE descriptions. So there's NIST, the National Vulnerability Database, which is supposed to be the source of truth, and they provide different scores. And then there's also the GitHub security advisories, and there's distros, right? If you're using Red Hat or Canonical, they might have extra information about the CVE. And so then it's at this point, we're just going to take that CVE ID and gather as much information as we can, as much current information as we can, to ask the question, just how would I know if this is actually exploitable in my environment? What do I need to check for in this container, in this environment, that's going to let me know specifically, is this an urgent drop everything and patch, or is this less urgent and I can make a VEX justification, or a reason, I can come up with a reason why I'm not patching right away. And so we do this with LLM. And this is a fine-tuned model that we've created with our cybersecurity experts. And when we first started building this earlier this year, that's where the process stopped, right? So we made this checklist, and then I handed it off to the analyst and the container security folks, and I said, is this helpful? What do you think about this? And they were like, yes, this process right here of scraping the web and analyzing all of this threat intel from different sources, you're already taking work off of my plate, right? Those are internet searches I would have had to do in the first place. And reading all those things, it's even just giving a summary of all those things is helpful, but then the actual actionable checklist at this point was really helpful for our analysts. And then the first step of this project was just getting feedback on this checklist and sort of capturing their process of thinking and fine-tuning this checklist task model. So this model has been given many names based on the many analysts that I think it was called P. Rogers for a while, Super Pete in the back. So this is essentially capturing all the human expertise that we have in the company into this fine-tuned, LoRa-tuned GPT-43 model. And so then once we get the checklist, that's when we're going to toss it to an agent model, right? Michael will talk more about the handoff between one model to another and why you want this agent model now has access to all these tools, right? It can look up code bases, web searches, all our internal documentation, Confluence, things like that. And it's going to execute the checklist for folks. So really unloading a lot of that work from the analyst into gathering more and more information and coming up with answers for these checklist items. And then that comes out for a summarization model, which is another fine-tuned model that we have. And then it'll even make a VEX justification. So further unloading that work from the human onto the LLM. And then we do have, obviously, a human review it, and then they can make decisions about publishing. So now, since you all are here today, we actually, want to get started with LLMs, and we want to. We're not going to show you how to build every single part of that CV exploitability and vulnerability analysis. We're going to give you all the pieces, and we're going to kind of build a mini version or a baby version of it, because you obviously all have your own infrastructure and things you'd want to hook it up to in your own designs. So. Today, what we're going to do, someone asked if there were any prerequisites, and the answer is absolutely no, right? We're going to start from the ground up with how are we going to programmatically interact with LLMs, and then we'll build up to making a prototype, and then we're going to end with actually spinning up your own microservice from the pipeline. So the plan for today, so we have it built in 3 parts. This first part is interacting with the pre-trained LLM using NVIDIA NIM. And so I'm going to go through the slides somewhat quickly, and then I'm going to hand it back to you so you guys can go through. I'm sure you've all probably ran through the notebook, but then you all can go back to your notebooks, and you can have some time to run through part 1 yourself. And you'll notice in the notebook it asks you, to stop here. So we're trying to divide it up sort of in a few different sections. So I'll go over this first LLM interaction part, and then you'll have a chance to do your hands-on activities. We'll regroup, and then Michael will talk about the prototyping. You'll have a chance to go through the prototyping section. We'll regroup and sort of work our way through the day that way. So the sections that you'll see in your notebook, I'm going to talk about up here. We have Python API calls, prompt engineering, prompt templating, zero-shot, one-shot, few-shot learning, and then we'll end with like some evaluation strategies that we can talk about. And so in your notebook, you'll see that we're using NVIDIA Inference Microservices, or NIM. And so this is our platform that hosts these large language models, right? And there is a chat interface, really similar to ChatGPT that you can use to interact with NIM, where it has a GUI, and you can just like ChatGPT, ask your question, get your response. But what we're doing differently with, I think, what we need for cybersecurity is we're building an event-driven pipeline, right? So we're not going to wait for a user-generated query to be sent to our LLM. Instead, we're going to interact with this using the HTTP API for easy code-based integration. And so in your notebook, you'll see the Python client library, Nemo LLM. And so it provides this simple interface. And the setup just requires making an object con, and then you can use the generate method on this connection. And there in the notebook, you can play around with different parameters. We listed all of them in the notebook. There's some interesting ones. So unlike when you're just interacting with ChatGPT in the GUI, you kind of get what you get as far as the output. But now that we're using NIM and interacting programmatically, we can we have so much more control of the output of what we want. And so there's the temperature, top K, repetition, penalty that I'm calling out here. And I think at the heart of all of these parameters that you can change is that, these are generative models, right? And so they're making choices about all the words or their tokens that they're going to output to you one after another, right? And so for every token that's generated, there's probabilities about which token comes next based on their occurrence in the training data, and then also your settings, right? So if I want to be using something for cybersecurity, really deterministic things, I'm not really interested in creative writing, I probably want a little more lockdown on the potential next tokens, right? And so I would encourage you to play in your notebook, see what happens when you adjust the temperature, or top K. And then also something that we see in some of these models is they loop on themselves, where they might repeat the same sentence over and over again once you start playing with these things. And that's what's so great about NIM, is that just you have full control over all these parameters. You're not waiting for OpenAI to update things or change things for you. And the second part of this, we're going to talk about prompt engineering, and this is where we can add additional context, or sometimes called a system prompt to the query, right? So rather than just inputting a query, we can add something that goes along with every single query. The example in the notebook is a persona. And so you can tell the LLM to act like you're a cybersecurity expert, and you'll see that you'll get different results than if you ask it to talk like a pirate. Which I also encourage you to do in the notebook. And I think a way I like to think about this is it's very limited. It's not a cybersecurity expert. It's telling an LLM what to do is sort of, you have to treat it like a child, right? So you need to be very specific and actually avoid saying what not to do, instead focus on what to do. So if you fill up the prompt with context about something you don't want, you're likely to still get that thing, right? It's like, you can't tell your kid, not to do something. It only puts that idea in their mind. They're gonna like totally go for it. And then so you should start simple, build up, and then obviously like test and iterate this process. I think if you've ever been in the weeds of it, you're like, why did this extra space or extra character like totally mess up my prompt? So you guys you'll have some time in your notebook to play around with some of those. Oops. And then I wanted to make a whole slide about prompt templating because I think this is a really important differentiation between chatbots and what we're trying to do here. Like I know there's lots of great information at GTC, and there's lots of opportunities to learn how to make chatbots. And I know since November 2022, everyone wants everything to be a chatbot. But we need something for cybersecurity, and we're building an event-driven pipeline. So we're triggering this pipeline off of this container scan, right? And so how are we going to take this automated process of container scans and get something to an LLM? We're not putting a human in between those two things. We don't want to wait for someone to ask the LLM, is this CV vulnerable in this container, right? The process is going to be in our control. And so to do this, to bridge this gap of events and interaction with an LLM, we're going to use a prompt template. And so the example that I have here and in the notebook, I'm asking for this checklist generation. And what I'm going to provide inside this prompt template is a space for all my CVE intel about a specific CVE to land inside the notebook. And so this example is the Pi Arrow CVE intel. You can see, and it's not magic, right? It's take this intel and place it inside this prompt, just like you were doing with your system prompt. We're going to add that, and then we're going to send that off to the LLM. So I think this is, I just want to drive home that we're not building a chatbot. We're using the LLM to advance our workflows. And then there's some next sections about zero-shot, one-shot, few-shot learning that you can try out. If you just zero-shot, it's essentially telling your child to do something, hope that they do it. One-shot, if you say, I know it's like, can you make me a peanut butter and jelly sandwich, right? And the jelly gets on the outside of the bread. And so for one-shot, if you show the LLM, if you tell it exactly what you're looking for, you generally have better results for what you want. But then you don't want to overfit to your one-shot example. And so sometimes few-shot, when you have like diverse examples, will make it more robust. And this is as straightforward as putting the examples in that prompt template I described. So context, and then you give it some examples, and you guys can play around with that in the notebook as well. In the last section, I feel like this should be, if you read my journal while we were doing these experiments and building this, this would like kind of be the overarching thing, right? How are we evaluating these event-driven RAGs, and how are we going to build Gen AI that actually works for the use cases we want it to work for? And so I want to share my journey, and then I want you to say it's also, I've heard this from many other places too. And so what we did is we started with an idea and a pain point from our analysts, and then we experimented, like you are today, with a few examples used it could be in a notebook, in VS Code, and we want to kind of take these few examples from analysts and try to build something out, do some prompt engineering, and then we're going to take those that first round of output, and we'll have our experts review it, right? And so we say like, oh, like what did you think about this checklist? Like what would you change? What's missing? And this like builds up a conversation of where the LLM output is today and where you'd like it to be. And so then we'll take that feedback and kind of iterate with our cybersecurity experts. And in that process, we're creating this larger data set, right? So we're saving all of that information and all of that feedback, and we're building up this data set. But the process isn't, hey guys, build me a huge data set. Like, I need a benchmark data set, I need to train my own model, please like build this up for me. The process is you wanna work really closely and really iteratively, and then just in the process of trying to make your prototype better, you will create this larger data set. And once you have that larger data set for benchmarking, you can use it for fine-tuning your own model. So I've seen, this was our experience, and I've seen it lots of places, and so it also kind of inspires this course where we're gonna get your hands on it today to kind of start in this few example box, and then that'll start the discussion with your experts on like how to improve it. And then over time, you can build a really great benchmarking data set. And so that also comes to why the notebook carries you all the way through production, right? Because you need to pivot quickly from I'm playing around on my notebook to I need to get these results to the right people, and I need this to be running in a semi-production way so that I can start building my data set. So that's sort of why we're doing everything in this order, where like, let's get started, let's play around with it, and then let's set it up so it's running and it's live and people can start giving you feedback on the output. So at this point, if you all want to get in your notebooks, I'm sure maybe you've run it somewhere. Yeah? They're not posted yet, but they'll be available to you later. Sorry. Yeah. Yeah. So, well, you all are welcome to work on your own and play around with the notebook, and I encourage you to do so. I'll be up here going through the notebook as well, talking maybe a little softer. I don't know.
Is it big enough? Talk through what you're doing.
Okay. So I'm hanging out in 1.1 section where I'm sending prompts to my LLM. You can see where I'm sending here as an example. How can one determine if a CV is vulnerable in a specific environment? And then down here, I'm going to uncomment this and play around with maybe some different models. Let's see. Oops. Oh, sorry. Oh, this is my fault. Yeah, if anyone has any, so the environment you're working in is a Jupyter Lab environment. And so it's running, you have your own T4 that you're working with, and everything's for you in the browser. And so the directory is over here. And if you don't see it, you can click on this file. And then the notebook that we're running is called Cyber Dev Day. And you can find it in the notebooks directory. And then you can see mine has a green dot because it's launched. And so you just double click on that to launch it. And then it starts up a Python 3 kernel here. And you can control what's running, you can stop it, you can refresh it, and then if you want to start from scratch, you can restart the kernel. And so I'll do that so I can run with you all. Does anyone have any? Yeah, go ahead.
We primarily work from that or the README file. No, the README files. Don't worry about the README files.
Yeah.
We're going to be slowly working in the notebook today, and it's just broken down into sections where we're trying to give you a little bit of background information so that you can comprehend kind of what's going on, and then there'll be a block at the bottom of the section that says hold here, and we'll all meet up and give some more slides, and then we'll kind of repeat that 3 times. So this first section is just kind of giving you an opportunity to experiment and understand how these LLMs work, see how we can actually get some more complex answers out of what seems like a relatively simple question, and how providing these background examples can really tweak and improve the answers that you get. Because this will be crucial to the final thing that we're going to be doing, which is going all the way and building up a microservice of a mini version of the agent Morpheus at the very bottom of the notebook.
And at the top of the notebook is a table of contents. So this first part that we'd like you all to work on through your own is this intro to interacting with LLMs, and we'll regroup and do some more slides for prototyping, which is the next section, and then beyond prototyping. Yeah.
Can you comment on the P? I played around with temperature and K, but is P just the bottom score?
Top P?
Yeah, so the minimum, it determines the minimum number of highest probabilities whose probabilities were some were equal to the top P value. So essentially, we have a token. You can get a probability for every token in the vocabulary as what's going to be the next one. And some strategies for deciding. One is you can use top K. If you set it to 1, it's called greedy, and it'll always just take that first token that has the highest probability. And so it doesn't care about any of the probabilities of the other tokens. But some other strategies are to say, take the top 5 most probable ones, and then you can get instead of, if you have 1 million tokens, the probabilities are really small for all of them. But if you just take top K, you can redo that distribution so that you have 60% is the probability for number 1, and so that they equal 1 for your top 5 or top 10. And then the top P will set a threshold, right? And so if you're saying, now I did top K, I have 10 tokens, and those probabilities equal 1, but then I'd also say, like, okay, I'm not interested out of that top 10 if any of the probabilities are below a threshold. So I just substituted Llama 2. This is a model from Hugging Face that we're hosting on NIMS, on a NIM. And I put the model name in here. And then I'm looking at the output, and it has what I was describing, this like repetition, where it kind of gets caught in a loop. And this comes from kind of this process of you're predicting next token, next token, next token. And if you don't have any creativity at all, it will just always pick the most probable next token. And that's kind of how you get in these loops. So I'm wondering if I change the temperature here, if that will help this model not get caught in a loop. So I'm going to try that now.
I So we have a T4 for running local computations. We'll be generating some like embedding models and building some vector databases later on. We're using our LLMs as a service, which is hosted in NIM, and we're calling via the API there, because there's no way we could start up a H100 for every one of you. Yeah, that'd be quite a bit.
On the setup environment, is there a shell code that you press when launching the shell to set it up?
What shell?
On the environment setup.
You start with 0, right? I mean, where's the button to launch the shell?
Oh, sorry. Yeah, it's a notebook. So when you're in the notebook, if you hold Shift Enter, it will execute the code in the cell. Yeah, it's not. We're gonna work solely in the Jupyter notebook.
Keep going.
So I'm looking now at just changes in the temperature for this output. And it looks like temperature 0 is actually giving very specific answers. And then with the higher temperature, I think I'm getting maybe more information. It's going into more different directions. Now I'm going to go down into prompt engineering, and I'm reading the example persona that we have. It's about being a knowledgeable cybersecurity expert. And let's see, I know previously we've been asking this question. Let's see if it's different once we tell the model that it's a cybersecurity expert. Yeah, so our previous answer to this question I don't think was as detailed. And so we asked this model in the persona to be clear, concise, and authoritative. And I think this is actually really important for if we're gonna trigger, actually execute a checklist, having this authoritative description in the prompt makes a big difference. This next one is for persona. And so I like this persona is fun. You're an elementary school teacher. Let's see how this changes. So our top one, we have a lot of the same information, it looks like. But now it's kind of, the answer is more casual, but also maybe contains the same information. A lot of times, a quirk of prompt engineering is sometimes models actually perform better if you're polite. So we can modify this to say, to ask it nicely, to please answer the following question. Let's see. And so now that sort of made everything a little more concise, as you would if you were having a more casual conversation. Now I'm going to move along to section 1.3, prompt templating. And I'm asking here, this is one of my, I think really helps tell the story of what we're trying to do, is we're asking this LLM if it can determine in the specific environment is affected by a specific CVE. And the model actually returns, it says, I'm sorry, but as a language model, AI cannot access this real-time information about cybersecurity threats, right? So it knows its limitations, and this information about this CVE from 2023 has no way to be part of its training data, since it was trained on pre-Gen AI data. And so we want to think about how can we provide, what are the ways we can provide this model the information that we need. And one solution, and the one that we're demoing here with you all, is to directly include the specific details about the CVE in our prompt. And this is what I was saying, I think is really important for this event-driven pipeline, is to have a mechanism for all of this up-to-date information that comes in, that's posted from NVD, the vulnerabilities database, of getting this CVE description into the prompt. And so these are two examples. This is the CVE intel for this CVE that involves PyArrow. This other example is log4j, which maybe you all remember. And we're gonna take this, we can take this information, and then we can just add places in the prompt template for these different sources of information. So now our model has access to this threat intel, and there's places in the threat intel for it to run. So let's see what the output looks like. Ooh, I didn't run it. Great, and so now we made it from up here where the model says, I'm sorry, I can't access that information. And with prompt templating, we've now come up with this checklist where we have the up-to-date things that we're gonna check for this specific CVE. And then we, so now I'm looking at, I'm gonna explore some different models. So these are all available, each one on our NeMo, or the NVIDIA Inference Microservice. And so there's a whole library of hosted models that are there for inference. They're obviously not running locally on your machine, so we're using our API call, but we can try all these different ones. And you can see in their descriptions, there's the B refers to the number of parameters each one of these models has. So obviously this one is the smallest here with only 5 billion. And so I'm interested to see how the output changes with these larger models. The dashes after them actually refers to some instruction tuning that has been done on top of them. And so I know I've heard in some places that these larger models aren't necessarily better than the smaller models that have really good instruction fine tuning. So I'm interested to see these outputs and kind of give them the vibe check. And now that I'm looking at them, it seems like a lot of them are hung up on this CVSS3 vector string. That's part of the intel for the input. It's the last part of the prompt, and it seems like they're having a hard time. But this GPT-43B, and it's also been instruct fine-tuned, this is the second version that's up there, is actually generating a checklist closer to what we're looking for. And one of the ways that you can intermediately evaluate how your model's doing is to come up with something that's really objective, right? So the example we have here is we ask the model to output its checklist as a Python list. And so unlike the actual vulnerability checklist that maybe is more subjective as to how accurate it is, this is pretty black and white, right? So how well is our model doing when part of its instruction was just to make sure the output is formatted properly? And so we can do this as a substitute, kind of as a proxy for an accuracy check. And so I'm interested to see how this model is doing. And it might be making a checklist, but it's still not completing my instructions to make a Python list. And so what can we do to help our model out? Since we want more, at least to pass this objective measure that we have for accuracy. And so now down here, we're going to start with this unparsable list. And so this is an output that came from a model, and we're going to just ask, this is the 0-shot example. If I just ask the model to parse this Python list, can it do it? And so it doesn't look too bad, but if I run my check, is this a properly formatted Python list? It's not. Can anyone see what, like, it's because it starts by telling you it's Python and tells you the checklist equals the actual list. Oh, and it's giving you the markdown. The checklist can be parsed into a Python list as follows, right? So we don't need we want the actual list as our output, right? We don't, it's sort of focused on being a helpful assistant and telling you how to parse it, but that's not going to be helpful for the rest of our pipeline, right? Because we need to take this Python list and then do some operations on it. So our one-shot example is let's put into the prompt, say, use the example as a guide and parse a checklist contents into a Python list. And we give it an example of the input, an example of the output, and then since it's generative, so with these prompts, you want to lead it all the way there. So the prompt then says given checklist, output Python list, and so we're encouraging it to the very next thing, the next token that should be most probable is the actual list. And so having this like very leading prompt where you make sure that if you were going to write the whole thing as one, the very next thing would be your desired output. So hopefully this will stop us from getting caught with markdown and instructions. So let's see how it goes.
How to create an agent to actually run the version and see, and you get a Boolean, yes, it's greater or less than. I mean, that's pretty straightforward, but I have to imagine some of the other things might be more complex. So is there something that you could launch, like an agent to go verify versions or contents of databases or something?
Yep, that's coming. That's exactly where we're going with this. Yep, that's correct. Yeah, so now with the one-shot example, we have a properly formatted list. And the question is, how robust could this example be? So let's see if it works with an enumerated list, since our example was using sort of the dashes. And so we had one example where the checklist was dashes, and it was able to parse that into a Python list. So let's see if it's able to parse a different type of list and see if it has any robustness. And it does look like it was able, even though the numbers changed, that prompt was robust to those formatting changes, and we have a parsable Python list. Let's see, and then this is the more sort of detailed prompt that we were describing. If you remember on the other side, we said like you want to start small and build up. I don't know if you all are experimenting with things. Sometimes it's tempting to find a prompt online that looks like this, that's really detailed and complex and has all these sections. And if you start there, life is going to be a little bit harder because it's harder to troubleshoot exactly what part of the prompt isn't giving you the answer that you want. But once you build up from sort of these smaller experiments and getting the output that you want, and you want just to iterate a little more on the content, then you can build up to these more detailed prompts. And so for this one, we're adding kind of some additional context. And then we're including multiple examples. So we have an example for this CVE, and then the output that we want. And then we have another example, and the output we're looking for there. And then we can also describe to the model the specific criteria that we're looking for. And these examples have come from this like fine-tuning process where we do a smaller prompt and look at the output and see what it's not getting quite right and maybe what it needs more explicit instruction on. And so this is how these prompts build over time, is you play around with it, you find where it's deficient and what you need to make more explicit in the next go. And so then you'll find yourself with this large detailed prompt. So let's see how that goes. And so this large prompt seems to be working well. We have the different things in time. Okay. Okay, yeah, okay, great. Okay, yeah. So now we're here with our large detailed prompts, and the output for PyArrow, this PyArrow CVE matches what we're going to use, right? So the question in the front was, the one we had before was, hey, this checklist is great. How are we going to actually execute and get the answers for it? And so we're going to build the prototype now. So go ahead. You can shorten the prompt. So there's a max token. I think it's 1,600 characters or 16,000 characters. Oh, to chunk the prompt. Yeah, so yeah, that's a strategy as well, to feed the prompt in separate stages if it does get too long. Yeah, that's not in the notebook, but yeah, that is an option as well. Okay, so at this point, we're going to switch back to slides for a second here. You're welcome to keep working, but I'm going to kind of go over this second part of prototyping. So we have our checklist. We're happy with the results. We've iterated on the model. We have a prompt we're happy with. And the results of the checklist have been vetted by some experts. And so the next stage is obviously, how do we execute this checklist? We've done our planning. We have an LLM. How do we give it the tools so that it can follow all these instructions that we've given it? And the examples in the notebook you saw where we're checking versions and packages. And so with a regular analyst at NVIDIA, we have signed SBOM, software bill of materials, that are available to them for our different projects. So they'll look up packages in these SBOMs. They'll do code, we obviously have source code available to them. And so we're trying to build this prototype with you all today. And we're gonna take this next step of providing these additional knowledge sources that are container specific for our prototype. And so I'm sure you all, this isn't the first time I'm telling you about retrieval augmented generation, right? So it's it's this process where we'll pretend that, instead of a user query, it would be the first item of our checklist, right? Is gonna come in and we're gonna ask the LLM, does this container contain pi arrow? And how can we give it that information? And rather, the one option is to do an exact match, right? You could have your LLM have access to a tool that does exact match, which is actually how we're doing the SBOM lookup today. But for some things, you're not looking for an exact match, right? Like if I want the LLM to have access to what's in the code base, I don't necessarily want it to have to look up exact specific functions. I want it to have more context around it. And so to do that, we don't want an exact search. We want a similarity search. And so what happens is the data source, in this case, a source code in the prototype, will take that and run it through an embedding model and store it as a vector database. And then when the query comes in, or that first item in the checklist, that checklist item is also embedded in that same space. And there's a similarity match between those two vectors. And that's returned to the language model. So we're not getting the exact match of what's going on in the question. We're taking the question and we're comparing it to everything in our vector database. And the vectors that are similar or close in space will be added to the context. And so the LLM will know what is in the source code without actually having to explicitly read the source code. And the process of doing this and building our prototype to have RAG is the first step is to build these vector databases. And so you choose an embedding model, right, which takes, it chunks up your source code. For the model we run at NVIDIA, it also takes any documentation and developer guides, and it chunks that up and it transforms it. Instead of text, now we're in vector space, right? And so this is, it's not a large language model, it's a smaller language model to transform from text to vector to a vector database, and that's how we're able to achieve this instead of this similarity search, so that we can get relevant context without having to do exact match. And so I'd like you, go ahead, yeah.
I think we talked about this yesterday.
Yes.
Yeah, so I did something like this. I tried to build a rack for my cyber knowledge base, but the problem is in the cyber world, we have entities like hashes, IP address, and they get chunked up before they get indexed. And then when I try to do the rack retrieval, somehow the information was not complete. And yeah, so do you suggest anything that we can, some strategy that we can do some chunking or some ways to overcome this?
Yes. So yeah, we were talking yesterday because you said, I have all this threat intel, and we put it all in a vector database, and then we wanted to find certain IPs in it, and you said it's really bad at retrieving IP addresses from a vector database, and it's like, of course it is, right? So it's like, that makes so much sense that if you embed IP addresses into vector space, and then ask the question like, how similar is this IP address to what's in vector space, you're going to get similarity matches, but you want exact matches. You're interested in that hash or that IP. And so if you have all these indicators of compromise that we all know are very useful for our current cybersecurity tools, you're kind of tripping over your own feet of putting it all into a vector database where you're gonna do similarity search. And so there's a lot of strategies where you can add extra information around. If you do have, let's say your threat, this is total aside. Okay, but maybe we should talk later.
You don't always have to use a vector database to do a similarity search. It is one tool that can give you near matches, but if you're looking for exact matches, you can use traditional database techniques to find, with this key that equals this greater than this, there are tools that you can use to perform RAG that don't require a vector database. Like if say you're using Milvus, for example, it does vector searches as well as just traditional searches. So you could just find my IP that matches this other IP and pull that into the query. So that's just what you could do.
Sort of a layered approach, depending on the data source.
Later on here, we're going to be adding additional tools, and so one of those tools that you could add is,
indicator of compromised database is kind of what I would suggest.
We'll point it out when it comes up.
Great. Yeah. So everyone, back to our notebook real quick. There's not a lot in this section. We're going to use this is the model name. To transform, and we're going to take our source code and generate our database. And this does take a second because unlike the API calls that we're doing to NIM, we're actually going to do this embedding locally. So it's going to download the model onto your instance, and then it's going to take all of the source code that is also on this instance. If you look back here, you'll, not there, okay. Oh, right, it's downloading it. Sorry. So we're gonna go, hopefully this is running for everyone. There's not a lot of hands-on activity besides getting this source code. We're using the Morpheus repo as our source code for this example. And so it's putting this in a Feist database. And then I think I'm going to hand it back to Michael, who's going to tell you how to get running this RAG pipeline. Now that we have all the building blocks in place, we have our prompt and our checklist, and we have our source code vector database. What are we going to do with it? So I'll hand it to Michael.
All right. I'm going to get through kind of just a section on kind of building out the rest of the pipeline, how you would actually use this, and then we'll have a short little break, and then we'll finish up with kind of evolving that prototype into an actual product, how you would scale it out, how you turn it into a microservice, and how you would customize the models. But before we can kind of get into any of that, we need to understand, we've done all this setup. We've figured out how to make prompts. We have figured out how to make a vector database that we can query. But how do we build something that's going to use this? We are not doing anything that's built off of user inputs anymore. It's all going to be event-driven. So if someone uploads a container, it's going to trigger an event, and this all needs to happen automatically. And so the tool that we're going to be using to actually run that is going to be Morpheus. We like Morpheus. I'm obviously the lead architect of Morpheus, so it is the tool that I reach for. But it is very well suited for this task. And we'll show you why, because it allows you to build cybersecurity-based pipelines that are high throughput and low latency, and we have first-party support for LLMs. So while you can do tons of other cybersecurity things today, we're going to be focusing on just how you would integrate LLMs just for this particular example, but I just want to make sure it's very clear that we have a lot of other use cases such as digital fingerprinting, sensitive information detection, phishing detection that you can use Morpheus for, and the concepts will be the same. So the first thing to understand how to use Morpheus is we have to first talk about the SDK. What we're going to be talking about today are these three big components. So the first is going to be a pipeline. We are building pipelines that are going to be efficient at moving data because they're going to be composed of a few stages. And stages are really important for Morpheus because it's a single composable piece of work. And we connect all of those composable pieces of work together via edges. All of those are going to be connected together, and if you were to make a long string, it's all going to start at a single point, and that's what we call a source. And so the source is going to begin the pipeline by emitting a piece of data. That data is going to be moved to the next stage where it's going to be processed, and then move to the next stage, and so on and so forth until we'll exit the pipeline. And if we see a little diagram here, it's going to look like, wow, my dots are off-center here on this plot, but basically as a piece of, back up a little bit. So as this first dot enters the stage, it's going to begin being processed by stage 1. And as soon as it's done, it's going to move that message onto stage 2. But it's not going to sit there and do nothing. It's going to actually pull the next piece of information to be processing. And that is going to happen so on and so forth. So you'll actually have multiple messages in flight at a given time. And we use this technique to increase the parallelization. So we can have a lot of data being processed simultaneously at different stages of the pipeline. And we can actually scale this out multiple times so that we can be processing multiple messages at each stage and multiple messages at different stages at the same time. So let's look at what a single pipeline looks like. So if we take that last graph and we turn it on its side, we now have the start up here and the end down here, and messages are going to flow from top to bottom. And this diagram right here is actually going to be executed by this piece of code. It's a little small to see here, but I want to illustrate this because you're going to see this in the code today, and we're going to actually be building these pipelines and using them and making small modifications to have large effects. So the first thing you need to do when you are building a pipeline in Morpheus is create the pipeline object. Today we're going to be working with what's called a linear pipeline, which means every single stage is going to have one input and one output. And the benefit of doing this is that they'll automatically be linked together. So we start with our file source stage. So this is our source. We call set source on it. And when you add a new stage with the add stage, it's going to automatically link those two together in the order that they were added. So you can see how each line corresponds to a location on this diagram here to complete the entire pipeline. This pipeline, what it's going to be doing is going to be reading some file from a source, pre-processing it into tokens, and running inference on it, doing some post-processing to find some detections, and then we're going to be rewriting those detections to a file. This is the core of our sensitive information detection workflow. And if we were to, we're going to be tweaking this today to actually run our LLM-based pipelines. And speaking of LLMs, we have an engine inside of Morpheus which is specifically designed to work with LLMs. The reason we made this is because working with LLMs have a lot of common patterns. You often have to bring in a lot of different services, like if you want to run OpenAI, or NIM or NEMO, or even the NV Foundation models. Services could also be like a Milvus vector database, like what we were talking earlier. And when you're working with a lot of services, it's important to run those asynchronously, which means that you're not going to be stalling the pipeline while you send a request off and wait for that response. While you're waiting for that response, the most efficient thing would be to start processing the next message. And so to do that, we are going to create a dedicated async IO loop to do exactly that. And we'll illustrate kind of the benefits of that later on in the presentation today. The last thing is just to note that we're not trying to replace any of these common libraries that you may have worked with, Llama Index, LangChain, or Haystack. We actually want to integrate them, and the LLM engine is just there to ease that transition between the patterns and practices that we have developed for building cybersecurity pipelines at Morpheus and those that are common in the kind of LLM world, and ease that transition so that they can all be linked together. And speaking of linking them together, the LLM engine is just a stage like everything else. So we saw the last diagram, which looked exactly like this, but we're just going to replace one of these stages with the LLM engine itself. And it's going to do the translation at the beginning to kind of a mini subgraph, we'll call it, and then at the end, it's going to translate it back for you. The point that I would like to illustrate with this is that this stage is just like any other stage inside of Morpheus, and they can be swapped in and out. So if you find a pipeline in Morpheus and you're like, oh, it'd be really great if I could just tweak this one thing, or I just really want to print out what's going on. All you have to do is just add that stage right in the middle of the pipeline, and the rest of the pipeline can remain constant, and it will it will run that as if you had built the entire thing together to begin with. So how are we going to run this RAG pipeline? So we have the LLM engine, we have the Morpheus pipelines, and we have to do this kind of complex step. RAG is a huge complex topic, and I don't want to go into too much, but it is important to understand what it's actually doing. And this diagram here illustrates what's happening It might be a little hard to read, but the steps are very, very common with RAG. You always start with a user query, which we are going to do some embedding calculation. That embedding calculation's entire job is to turn your query into a vector so we can find other pieces of information in our database which are similar to it. This is going to be your background information. So if we're asking for, do we use PyArrow hotfix in the code? If we aren't using something that's exactly that exactly matches this string but might have a few words that are the same inside of the code, we would like to know that. Say we're doing import PyArrow hotfix. And so what's going to happen is it's going to find in this retrieve step, all of the pieces of code that are somewhat similar. And we're going to hand that all to the LLM via a prompt template, which you were doing in the last section, to build up one big query. It's going to say, we are looking for this piece of information. Here's all the source code that are kind of similar. Please answer this question. And that's going to be one big prompt template. And we're going to send that off to the LLM, and it's going to come back with an answer. Yes, you are using it. No, you are not using it. And that's kind of the final step. This is a lot of work. It's too much to build, and it's very, very common. So what we've done is, well, we've just made a stage that does that automatically for you, and it's called the RAG node. You just have to supply it with your template, an LLM client for how you want to interface with that LLM, whether that be OpenAI or some local resource or NIM or an NV Foundation model. And the last thing is you just need an embedding function. And that embedding function is going to be kind of specific to your problem set. If you're doing something with IP addresses, it's going to be very different than if you're working with dictionaries. There's ones that are very specific for code versus just normal text, or say like Reddit posts or something. And the advantage of using this stage is it's going to work very similar to any LangChain, Llama Index, and Haystack RAG pipeline, but we have some built-in support for working with Morpheus, automatic logging, error retrying, and it's all asynchronous by default and works within our pipeline. And so the final pipeline that we're going to do is going to be very, very simple. It's actually just 4 stages. We're going to read from a data frame. We're going to deserialize it, which just means turning that data frame into a message that the pipeline knows how to work with. We're going to run our LLM engine, which is going to execute that RAG, and then we're going to just display it to screen. And so let's take a look at that. And so this is where we're going to go back to the notebook. So if we pick up here at 2.3, encourage you all to, most of what I'm going to be saying is already in the notebook, so you can choose to either read along, or I will be talking about it because it's good to just show some of the finer details. Now, when working with Morpheus, we always need a configuration object. The configuration object is kind of your global settings. Think of that like the number of threads, the verbosity. In this case, the type of pipeline that you're running. This is going to be a custom one, so we set it as other. There's not too much that we need to talk about this, except that it needs to be created and it needs to be passed to every single stage. So we're going to hit Shift-Enter on that, which will create the pipeline configuration. And this is where we're going to get to the crux of what the Morpheus RAG pipeline looks like. What you're seeing in this next block is all of the code that is necessary to build the entire pipeline. It's a little verbose because we're importing a lot of things, but if you get beyond this, we're going to start at the bottom of the screen, which is a little counterintuitive. And we see, if you can't see this, it's also right in front of you. This is where we're going to create the pipeline. We're going to set the source as the in-memory source stage, which will just read from this data frame. Then we're going to add this LLM engine, which we will build the RAG LLM engine, which is right above this, add the in-memory sync, and then we're going to run this. And then the last part is just displaying the output of that result to the screen. The LLM engine code here, as I said, there's 3 things that you need to provide. The first is the prompt. So we're going to say, this is the persona. You are a helpful assistant given the following background information, which is where we're going to iterate over every single source file that comes back from our RAG database. Please answer the following question. So this is the prompt templating section that we were talking about earlier. So that is the prompt. That's piece 1 that you need for running RAG. piece 2 is the vector database query. So we're going to be reading the vector database that we created in the previous step. So we want to load all of the code into the database and search that. And then the final piece here is just the LLM service. So today we're going to be using one that you supply via configuration file, or just like a little dictionary. And then we're going to be building a client from it. And the last step is that we just add our RAG node. If anyone's familiar with Haystack, this syntax is nearly identical. So you just pointing that out if anyone is familiar with it. And so let's go ahead and run that. And the model that we were using before was kind of our like GPT-43B version. But today we're going to be using a different model, or for this example, we're going to be using a different model, which is called Mixtral. We've had good success with this model, and we're going back to our same exact problem, because I love this question. Are we importing the PyArrow hotfix inside of the Morpheus package? So let's run this and see what happens. Now we have verbose logging on, so it's going to tell you all of these steps about building the pipeline. It's going to tell you each of the stages that get added and the settings that were used for each of these stages. We'll see that it has to do a batch size of 1 because we only have 1 query. And then the pipeline is going to be complete, and we're going to print the response that says, yes, PyArrow is imported, and it will tell you the exact file where it is. And if you were to cat this file inside of your environment, you'll see exactly that we have used the PyArrow hotfix, which is the root package of Morpheus. So it's quite smart. It knows that this is the root package of Morpheus. We are importing it, and it can be found at the end of the file. If we copy this and open up a terminal, cat, oops. See the contents of this file. Let's see, here we are, the CVE mitigation. We are mitigating this, and it's imported somewhat towards the end of the file. Not quite accurate, but we are in fact using that. So to me, this is, I think it's pretty cool because it knows exactly where it is. It knows that this is the root of the Morpheus repo, and it's correct. So we're going to be building off of this and doing this type of work, but many, many times in rapid succession in the rest of the pipeline. But while RAG can be really powerful, it does have a little bit of limitations. And for example, if we were to ask it a question such as, does the code repo use LangChain functions that are deprecated? Will it be able to answer this question? Will RAG work for this? If we rerun this section here, we'll see the exact same things, that we built the pipeline, we added all of these things, and our response down here is, based on this, I don't know. It has some utility functions, but there's no mentions of LangChain. This is a little bit different than what we got when we were building this notebook yesterday, because that's a little, kind of how some of these LLMs work. Yesterday we were getting this is, I can't determine this. And the reason for that is quite simple. If you think about that question, does this code repo use any LangChain deprecated functions? You need a lot of information to answer that question. It's a seemingly simple question, but you need to know, well, what version of LangChain are you running? I need the developer docs of LangChain to find which functions are deprecated. Then I have to search the source code to see if we're using any of those. And that requires a lot more information than we have provided. We gave it access to our code database, but we didn't give it any of that other information. And even if we did, looking at this pipeline, how would it know which one to choose? It could choose one for one question. It would need to choose another for a different question. And the short answer is, why don't we just ask the LLM what it needs? We can say, here's all list of tools that are available to you. What do you need to answer that question? And that is precisely what we're going to do. And we're going to be using agents. I think someone mentioned agents over here to begin with. But LLM agents are really, really powerful because instead of having a fixed pipeline, you let the agent reason with itself. It can say, I need, to answer this question, this is the information that I need to know. So you might say, going back to that example question, it would reason, I think I need to look at the code for all instances of the PyArrow hotfix. And then what it would say next is, okay, so to do that, I'm going to execute the action called the code-based QA system. And in that action, I'm going to put this input, which is my question, and then the tools are going to answer that. So that's where the RAG piece is going to come. It's going to go ahead and execute that tool and give you back an answer of all the places in the source code that might match that answer. And then we're going to pass that right back to the LLM and say, now that you have this information, what do you need to know next? And this is a loop, so it will keep doing this until you get to the last stage where the LLM will actually say, I now know enough information to answer the question, and it will say final answer, just like in Who Wants to Be a Millionaire? This is my final answer, I'm done. So this loop can do 1 iteration, it can do 10 iterations, it can do anywhere in between, and it's going to be specific to the problem at hand for how many times you iterate through that loop. And what's interesting about this is that the tools that you provide it can be customized and built for your specific use case. So today we're going to be using 2 tools. We're going to be using the one that we just created, which is the vector database containing all of our code. And the second is going to be the software bill of materials, which is called an SBOM, which allows the LLM to say, are we using this software package? And if so, what version are we using? And it's a really simple dictionary lookup. But just providing that tool allows the LLM to then do some more complex reasoning, like, okay, are you susceptible to this? Do you even use it in the code? Are you less than this version? And that's, if we think back to the checklist that we created in the previous step from Rachel, those are the exact questions that we need to actually evaluate whether or not we are exploitable and vulnerable in to that particular CVE. So these agents are really cool, and we'll show you how to interpret the output because it can get a little bit more complicated, but we now need to put these 2 pieces together. So we have our checklist model and we have our agents, and how are those going to run together? And that's our super creative checklist and execute architecture, where we're going to break up the evaluation of each CVE into 2 different steps. The first step is going to be generating that checklist, asking the LM, what are all the things I need to investigate, just like a security analyst would do. And then for each checklist, we're going to run an LLM agent chain to answer that item. So it's going to say, okay, I've figured out what the answer to this is, and then the last step here is just going to be to take all of that output and come to some final conclusion. In Agent Morpheus, we have a whole other model to do this, but today we're going to leave that as an exercise for the reader to look at the output and kind of come to your own conclusion, because it is a little too, 2 models is getting kind of up there for a single DLI. So, simple question you might be asking is, can't you just do this all with a single agent? Simple answer is, probably, but we can run all of these at the same time, which gives us some nice performance benefits. We get a much more complete example because you can kind of see how the entire thought process of the final decision, and it gives a lot more context to this particular model, which we fine-tuned on from our security analyst to say, given all of this information, please come to a conclusion. So what does our Morpheus pipeline look like? So if you remember before, we had a simple 4-stage thing. All we're doing is replacing this LLM engine with this new pattern, which is going to be the single model into multiple models and then back to a final conclusion. We're going to be using two new nodes. So before we were using the RAG node, which was part of Morpheus, but what we're going to be using is a new customized node called the checklist node, and that doesn't exist in Morpheus by default. It was custom built for this, for Agent Morpheus, and then we brought it over here, a very simple version of that into the notebook today. And then the other node that we're going to be using is just a LangChain agent node, and it does exactly what it says. You build an agent in LangChain, and then you can run that inside of Morpheus. If you say you've done a bunch of prototyping in LangChain and you're thinking about using Morpheus, and you're like, well, I don't want to redo everything. You don't need to. Just bring it right in. Run it in one of these nodes that will run it exactly as is. I don't want to draw the diagram for this because I tried that and it got a little too complicated. So it's all in there. And if you're curious to look at the implementation, it's up here into the Cyber Dev Day checklist node file. You can look at it, but it's, it's quite large because it's quite complicated. Getting back to our slides here. The last thing before I kind of set you loose to try this out is how do we interpret the output? This is nothing specific, but when you're looking at these notebooks, I want you to understand what's actually happening when you see the output. The top, you're going to see something that kind of looks similar to this, mainly the bottom section here. The input is going to be what comes from our Intel data feed, the prompt templating that we did before. We're going back to that same PyArrow example. So this is going to generate these 3 checklist items. We did that by hand in section 1. We're going to check for PyArrow, we're going to review the affected versions, and then we're going to check for any vulnerability mitigation. I like this particular example, and we chose this example because it's one where traditional CVE tools fail. We have already mitigated this in our software, but the file in question still remains because it hasn't been patched in their repository yet, but there is a hotfix out there. So we have mitigated against that by including that hotfix in our code, and every single time we run a container scan, we don't want to have to investigate this over and over and over again. And can the CVE tool tell us that we are not susceptible to it anymore? And if you expand that and you get 300 CVEs or 1,000, which we've seen in some containers, being able to do this on a large scale can be very, very powerful. So let's look at kind of the output. So the first item is almost always like a false positive check. Just want to make sure, like, okay, the CVE said that you have this in there, but do we actually have it in there? So the LLM comes out with, yes, the project uses the PyArrow library version 11.0. The next is our version part of the affected version? So are we less than 14.0.1? And we look at the output here, it's really tiny to see, but we are 11.0, and the affected versions go up to 14.0. Therefore, we are affected by the vulnerability. This is, the LLM is actually capable of determining, some version, is this less than that? And then the final piece is review code to check for vulnerability mitigation. And the last piece says, yes, the PyArrow hotfix package is imported in the Docker container as a mitigation for the risk of arbitrary code execution. I think this is a particularly cool result from the LLM agent because not only is it saying, yes, I found that package used in there, it's using the PyArrow dash hotfix instead of PyArrow underscore hotfix, which is the name of the package versus the name of the Python file. And it's actually pulling the information, risk of arbitrary code execution, that comes from up here. So not only is the agent able to go through, reason all the steps, but it's able to pull from the original information. Why were we doing this in the first place? And so the last thing is then you just need to take this entire output and come to some conclusion. So if we don't have a false positive, we have the affected version, and we are mitigating it, are we vulnerable to this? And the simple answer would be no. We could get an exclusion for this. So let's go back to the notebook. And after this section, if you're done, we're going to take a 15-minute break just to get up and stretch your legs before we go into the final area. But please, feel free to either sit here and work or get up as we go through at your own speed. So we kind of covered the agents. I already talked about this, but if you wanted to see, this is a pretty generic description of how it's functioning. We're using the React framework from LangChain, which has been developed by a bunch of data scientists and released on LangChain. And how it actually works and the patterns that it does, it's too much for this talk, but the basics are basically telling the LM, you have access to these tools, here's your question, please follow this pattern, and you kind of loop on that. We'll see that come out. Here's the pattern, so we would say, here's your query, I need to check the LangChain's version, I would like to use this action, now my observation is this value, and it says, well, what do you need to do next? So the LangChain's thought is, I know that this is version 0.1.2. I need to check the source code, so it will use a different tool. and it rinses and repeats, and you'll see this kind of final answer at the bottom. This output you will see inside of the logs. They might be interleaved because we're running multiple agent chains at the same time. But if you see this in the output, which you will hear in a second, that's what's going on. So moving down into defining the Morpheus pipeline, it's nearly identical to what we did before, except that instead of doing the LLM engine stage with the RAG pipeline, we're just swapping it out for the CVE engine, and everything is exactly the same as it was, so we can just go ahead and run this function. This is defining a function up here called the run CVE pipeline. We're going to be using this throughout the rest of the code. All you need to do is supply a configuration object, the engine configuration, and a list, a CVE that you want to investigate. For this particular example, we've tried to simplify things. We've found with the CVE pipeline and a lot of Morpheus pipelines that the number of configuration choices kind of grows, and it's easy to just contain those all into a single file. And so that's what this here is. It's just an engine configuration file. So you can specify what type of model you want to use up here. The temperature, top K, tokens to generate that you saw in section 1, and then what model we want to use for the agent, and we need to load some actual information. Like we are running this live, so we need the SBOM, which is located in this container. And then the last thing is where is that code repo embedding vector that we created earlier, and we specified that path in the last section. So we will create this, and if you ever want to modify this or change it, you can just come up here, change the value, and hit Shift Enter again, and then rerun the pipeline. And if you ever want to see what's actually in your configuration, you can just print it to the screen like this to kind of see what we're working with here. All right, so let's run this pipeline. We're going to take our threat intel that we did before, put it into some templating, and then let's run the pipeline. So the output gets a little long, so it's going to go into scrolling mode here. So we'll see entering new agent executor chain. Remember, this example is going to generate 3 different checklist items, which means we're going to run 3 different agent executor chains. And we see that pattern that we were talking about. It says to check if the PyArrow is present, I need to use the SBOM package checker, and I'm looking for the term PyArrow, and we'll see out here that the result it gets is 11.0. Now the output gets a little bit interleaved. That's why it was important to show you kind of what was happening, but this is the response. So I encourage all of you to kind of look at this. So it says, yes, this is, I don't need to repeat it because this is exactly what we showed in the slide. Now, this is kind of the crux of the entire CVE tool, and this is what we wanted to show of how you can take everything from prompt templating and these personas, vector databases, LLM agents, and actually get something useful out of this. And it can scale. We can run this automatically every time there's a CVE, and it can pull this information in from CVE resources, and it can do so in a very, very fast manner. But it does have its limitations. And the last section that we're going to talk about before we get to our break is hitting the limits of the LLM. Before we use the PyArrow version, we're just going to switch this out for a log4j, which is exactly identical. I think we can scroll up earlier in the document and see, sorry, I thought it was closer, what, I'm not sure exactly where it is, but they're very similar. They're just, it's a seemingly innocuous prompt, and if we rerun it in that section, we'll see what happens. We get a big ol' exception, and the reason for that is because for some reason, when we switched from the PyArrow CVE to the log4j CVE, it's not able to generate a valid Python checklist. As we were talking about earlier, it just can't parse the output of it because it gets into this repetitive pattern where you'll see check if it's used in the project, and if it is, and it says check if it used, and if it is, and we'll just keep repeating this ad nauseum. And that's because we're using the default model. And we'll talk about ways to mitigate this later and actually fix this problem. But that is for the next section. So this is, we're going to give everyone a 15-minute break. So we'll just, if you have any questions, now's a great time to ask. But feel free to get up, stretch your legs. We'll be back here at 10:05 for the last section, and then we will move into our presentation by CrowdStrike.
just need someone in my life to give it structure, to handle all the selfish ways I'd spend my time without her. You're everything I want, but I can't deal with all your love. You're saying I'm the one, but it's your actions that speak louder. Giving me love when you are down and need another. I've gotta get away and let you go. I've gotta get over. But I love you so. I love you so. I love you so.
You are so sweet, dancing to the beat. There's a meat market down the street. The boys and the girls watch each other eat. You are so sweet, so sweet, dancing and moving to that beat, that beat. There's a meat market down the street. The boys and girls watch each other eat. The boys and the girls watch each other eat when they really just wanna watch each other sleep. But they want to watch each other sleep, sleep, sleep. But they want to watch each other sleep, sleep, sleep. You are so sweet. Once more. You are so sweet.
Solo.
I went walking through the city like a drunk but not, with my slip showing a little like a drunk but not. And I am one of your people, but the cars don't stop. And I am one of your people, but the cars don't stop. It's been a long time since before I've been touched. Now I'm getting touched all the time. And it's only a matter of whom, and it's only a matter of when. An addiction to hands and feet. There's a meat market down the street. The boys and girls watch each other eat when they really just wanna watch each other sleep. An addiction to hands and feet. There's a meat market down the street. The boys and girls watch each other eat when they really just wanna watch each other sleep. Oh, they want to watch each other sleep, sleep, sleep. But they want to watch each other sleep, sleep, sleep. They want to watch each other sleep, sleep, sleep. They want to watch each other sleep, sleep, sleep.
Life's too short to even care at all. I'm losing my mind, losing control. One more spoon of cough syrup now. Whoa, whoa. I see you standing here, but you're so far away.
All right. Thanks, everyone. We're going to try and get back to the last section of the presentation before we're going to hand it off to CrowdStrike. So if you can take a seat and we'll get back to it. All right. So we've gone through the prototype. We've kind of just showed the concept, but if you were to try and put this into production, you're going to run into a few troubles. So the last section that we're going to talk about is how you would turn this into a product and some of the ways that Morpheus is going to help you do that. This section is less about experimentation and more about just showing you the tools that are available in Morpheus. And some of the challenges that you might run into if you were to do something similar. And then at the end, we'll hand it off to CrowdStrike to show some other use cases of how they've integrated Morpheus into their platform. So if we look at the prototype, and I would say, what are all the things wrong with it? We ended up with a problem where we ran into an exception. And that, first off, we got to fix that exception. We need a better model that can more reliably generate output that's not going to get into this loop. As much as you want to add more examples to it, it's not always the best solution. So there are tools at NVIDIA that can help with that to improve the model. So that's step number one. The next one is we are only running one CVE at a time here. You run it, you get the output of one of them, but that's not really scalable. We've seen containers that have 1,000 CVEs. Our own, when we first started this, had 300 that we had to go through. And how do you scale that up, and how do you run this in a way that's going to not crash your system or take forever? So we'll talk about that. And then the last thing is reading from a file or reading from memory in Python. That's not going to hook up to any other system. So we're using this in production today. So when we get a container scan, how do we trigger that pipeline? So we're going to turn the example that we were working with into a microservice, and we're actually going to show you how to send a curl command to it to trigger it scanning more and more CVEs, just as you would if you were to integrate this into a different solution. So let's get into the model. So we talked about we need a better model. The base one is good. It can get you good results, but it's not perfect. And one way to improve that is, we talked about with few shot, but at the end we saw if your context gets too big, if you are putting too many examples in there, it's not always the best solution. Number one, you pay per token when you're running LLMs, so the longer the context you have, the more it actually costs to run that query. And if you're putting this big block of the exact same information in there over and over again, you're just going to repeatedly pay to tokenize that first section. So the longer you make it, the more overhead you're going to have on a per query basis. So we want to improve that, and by fine-tuning the model, we can go from few shot to maybe one shot and even 0 shot. And that can save you cost, it can improve performance, and it's relatively easy to do. And I'll actually show you how to do that. I opened up, oh, Rachel, do you have it logged in? All right, well, let's try, can I go to NGC? Sorry, I signed in on my computer. No, we got it. Okay. So on NGC, we actually fine-tuned this model by going to this Nemo LLM section, and we can customize the model. Can I make this bigger? And part of the customization is that you can make your own customization by uploading your own data set, which is down here. And the data set's really just going to be like, given this input, so for this CVE, what do I want my checklist to be? And if you make, say, 100 samples of that, you can train a new LoRa-based model with specific hyperparameters. And we have this training data here. And we've actually done that for you already today. And we will see in this shared with us, we can see here's our dev day checklist data set 43B that we've actually already trained. And this improves the accuracy a lot. We will show how you can use this in the notebook to fix that error that we had at the end. And all we need is this, this customization ID, and it will suddenly work. That's really, really quite nice. But if you find that your model is not performing exactly as you want it, this can be a very powerful technique that is quite cheap compared to training from your raw samples. Let's see if it's going to work. It's got some cool visual outputs. Here we go. On like you can see the training loss, just like you would in like TensorBoard, and the validation loss. It's a very powerful technique. And there's a lot of things that you can do with NeMo. This is straight from the NeMo LLM developer website. It can help with prompt engineering. This is parameter efficient p-tuning as well as just full fine tuning. It really is a whole set of tools that can streamline this, and it's not difficult to use at all. I've done demos where I actually run the training live and increase the accuracy, in like 20 minutes, which is it's really cool. So let's go to the next thing. So once we've improved the model, we need to run this for multiple CVEs at a time. And it's important when you're working with LLMs to understand how you're actually running them. If you're not careful, the time can add up. Sometimes LLMs can run pretty slow. Say it's 100 milliseconds best case, but can take 1 second worst case. We're going to kind of assume 1 second here. And if you were to run this generate checklist up at the top, and then waited, and only ran one of the agents at a time, say there's 3 steps for that agent, and then did the next one and the next one. When you run this whole thing serially, that could take 11 seconds, assuming you're running one extra model over here. What you want to do is, what we've been drawing here is you actually want to run these fully in parallel. And to do so requires, asynchronous code execution, which is by default on in Morpheus. And you can get some drastic speed improvements. This will run 2.2 times faster. But where this really comes into effect is when you start having multiple CVEs. If you're running 3 CVEs in a row, even if we're running them kind of parallelly within each other, but we're not running them all at the same time, now it's taking 15 seconds to run these 3 CVEs when we really want to be living in this world where we're running everything all at the exact same time. In a perfectly, perfectly ideal world, parallel execution will be a fixed time. That's because it's just going to take as long as your longest runtime to work if you're perfectly parallel. And a sequential or serial execution will scale linearly. So every time you double the number of CVEs, you would double the runtime. And this can really add up. If you're only doing 3 CVEs, you might be 6.6%. Go ahead.
Does this have an impact? I'm just trying to think. Does it have an impact like on pricing? What's the practical impact?
So behind the scenes, we're caching all this. So yes, it can. But if you do some effective techniques on caching, if you're running repeated things over and over again, you won't actually be charged for it. But yeah, I mean, it can add up. I will tell you that it doesn't get that expensive. We were using OpenAI for a month on this thing, and it cost us $100. You really have to be running this a lot for it to get to the point where it's going to cost a significant amount. And just running this many queries, relatively infrequently is not going to be super expensive. But if you were to say run this on your own machine, if you got an H100, you can run TensorRT LLM, and you're just going to pay for the H100, and you can run as many LLM queries as you want. The reason you're charged on a per execution queries is just a very efficient way of having a usage-based pricing model that works really well. Because today we would spin way more up than you could handle with a single server across all of you. But that's what NeMo is. NIM is here for. It's actually going to distribute it across like a whole cluster and run all of these queries for us. But getting back to the serial versus parallel execution, the important thing that I just want to show is that like this can really add up. I'm talking about if you run 3 CVEs, it might take 30 seconds to run, and if you ran it in parallel, it might take 5 seconds to run. But if you're running 300 CVEs, you're talking about nearly an hour in a serial environment versus, again, it should only take 5 seconds. Now, we're not in a perfectly ideal parallel world. There is some execution. We're running the embedding model locally on all of your own servers, so there is some processing that we can't perfectly parallelize. And so if we wanted to see how close we are to that ideal serial versus the ideal parallel, I can just plot it. So this yellowish line is what you would consider for a serial. The green is the perfectly parallel. And the blue, you'll see this in your notebooks. This is an actual runtime that we did. We are much, much closer to this perfectly parallel world than we are in the serial world. So we have much more efficient scaling because we're able to overlap all of those executions in Morpheus at the same time. Remember how I talked about when you send a request off, the most efficient thing you can do while you wait for the response back is to start processing the next message. And so that's what we're going to be doing here today is we are going to send off a request, and we're going to send off a request, and we're going to send off potentially 600 requests, and then as soon as they come back, we're going to start processing them and send off another request and keep doing that over and over and over again. So this plot is actually in the notebook. And then the last thing is, how do we turn this into a microservice? I've been showing these charts this entire day for this one simple purpose of how easy is it to turn the pipeline that you've been running into a microservice? Well, we talked about the source stage. If you're just reading from memory, it's going to read the data frame, and it's just going to emit it in the pipeline, and then it's going to say, I'm done. And as soon as that message passes all the way through the pipeline will exit. But what if you just didn't exit? What if you're just like, oh, I'm going to wait for more information? It will keep the pipeline open, and now we have turned this into a microservice if the thing that is keeping the pipeline open is listening for HTTP requests. Now, how do you do that in Morpheus? It's as easy as just changing the stage that you're using for your source. So instead of using the in-memory source, we're just going to swap it for an HTTP source, which is an HTTP server source, and now we have a microservice. And you can then send curl requests to this. Every single time it gets a curl request, it will process the body of the payload into a data frame, and it will send it into the rest of the pipeline, just as it was if you had read it from a file. And so this is an important concept in Morpheus because any 2 stages can be swapped out as long as they have a compatible interface. So if this is emitting data frames, you can use any other stage that emits data frames. If you want to put something in the middle here, as long as it accepts data frames, you're fine. After this point, we're working with something called control messages. And if you put something in between the deserialize and the LM engine that works with control messages, it will work. And so this is a powerful technique in Morpheus to turn something from a debugging and a development world into a production world. I can guarantee that everything from here down works exactly as I want it to. And then I switch over to running this in production. And all I do is swap the source out, and we're good to go. If I want to, say, add something in here that monitors the throughput, I can do so, and then I can just remove it when we go to production because it's not necessary. So that is the what we want to show. So if we run this inside of our notebook, let's get back to our notebook. In the beyond prototyping section, so we talked about those 3 techniques. Now we're going to actually run the 3 techniques. So we got to go. Let's back to improving the model. We ended the last section up here with an exception. We're not able to parse this output because it's just repeating itself a lot. You can see check if this library is used, and it says check if this library is used. It's going to keep doing this over and over and over again. If we swap this out, and we want to isolate this from the entire pipeline because it's just easier to see, so we'll recreate it here. We should see that output that's not parsable. If we swap out the default model, which is this LoRa model, with our LoRa model that used the customization ID from Nemo, and everything else is the same, and we rerun that, suddenly we have a parsable and concise list. So this is you know, a very powerful technique that you can use to kind of guarantee that you are getting the results that you want. I like to always think of LLMs as just like small children. You've taught this child, he's finished his 4th grade, and now he knows how to do it without a lot of instruction, and it's gonna give you the result that you want back. So if we use this model inside of the pipeline, we should see it work. So the easiest thing to do is we don't want to pollute our old engine configuration, so we're just going to make a copy of it, and then we're going to swap this customization ID out. It was none before. We're going to supply this, and then we're going to rerun the exact same thing that crashed before, and hope that it doesn't crash this time. So we'll see it's going to, the fact that it's making it to the agent executor chain is, means that it's got past parsing as we had errored before, and we get all the way down here past all the agent chains to the bottom, and we'll see the final responses. It's not important what the content of these responses is. What we just want to show is that a seemingly innocuous example, like if we're working from a log4j vulnerability versus a PyArrow vulnerability, for some reason one broke and the other one worked. And if we use fine-tuning or p-tuning of our model, we can fix the one that broke, and now we can continue running. And that's what we've been doing for Agent Morpheus. We've been iterating on this. We've been fixing these edge cases. We've been training the models and improving it, integrating the feedback from security analysts, building up these training data sets, and we are using multiple customized models. So not only are we having one customized model for the checklist, we have a customized model on the other end for determining the summarization, and also one for the VEX justification. So scaling the pipeline, I already talked about these images, but let's run it. So if we scale this up, it's as simple as just, let's put a little ×3 in here. So now we have, instead of one CVE that we're going to run, we're going to actually run both the PyArrow and the log4j, which means that there's going to be 2. We're going to multiply it by 3, so there's going to be a total of 6 agent executor chains. And when we run this, you've probably already seen this block before where it's entering new agent executor chain. The fact that these are all right next to each other, confirms that we're doing, we're overlapping these agents together. But, well, let's just run it. Let's see what we get. So we'll see here in the output, it's going to generate a lot of output. Just keep that in mind. And now we can see not only were we doing 3, but we're doing, look at all those that get fired up at the exact same time. There should be a total of 7 times 3, 21 different agent executor chains that all get fired up at the exact same time, which confirms that we are not just running one set of CVEs in parallel. We're actually running all 6 of the CVEs in parallel at the same time. And as I mentioned, we're caching the results, so we're not hammering our LLM. And we get all the way down here at the bottom, and we see the responses for each of these. So in Agent Morpheus, we're doing this. We will fire up 100. We do it in batches of 100, and we get 100 responses back, and then we take that output and we actually display it in a user interface for people to kind of the security analyst to take that, understand if they agree with it, then they will go and fix it. If they disagree with it, they will make an exception, which goes into our training data set, and we kind of iterate. We improve the model, we improve the pipeline, and we give them better results, and we just build up this loop. Now, let's confirm that we're actually running in parallel. How do we generate that graph that I showed in the slides? What we're going to be doing here is, first off, turning off this super verbose logging. The next thing is we're going to run 1, 5, and 10 examples at the same time, and then we just have this nice little utility called log time that's going to count how long it takes for each of these to run. And if we run that, we'll see on the output here. So one CVE took 1900, then 2500, and then 2600. So our scaling looks to be pretty dang good. So if we plot that chart, you can see the blue line here, we are much closer to this perfectly parallel and ideal world. and we are far, far away from the serial line up top. So the last and final thing that we want to show in the notebook today is turning this into a microservice. I talked about this earlier. All we got to do is swap the stage out. So we're going to repeat the entire pipeline microservice code as we did before. The only difference is that this time, instead of doing the from file source, we're going to use this HTTP server source. We're going to look for results on the scan endpoint. Make this a little bigger. On the scan endpoint here, on port 26302, I just picked a random one. And the payloads need to be kind of in this JSON format, so it's parsable into a data frame. And we need to know like when this is triggered, because there is a delay between when you send the request and when you're going to get the response back. And just for this purpose, it's really helpful to see that immediate feedback of when we've gotten a request. And it also was really nice to define, how do you make a custom stage in Morpheus? This is it. You just add to a single function this stage decorator, which means that we're just going to take our message. We're going to print this line that says, we got a request. Here's the payload of that request. And then we're going to send it on to the next step. And we just add this to our stage. You could comment that out, and nothing bad would happen. But this is just very useful for us to run it. And then from here down, completely identical to what we were doing before. So let's load that up. And when you're running this on your own, remember that it's not going to end. The pipeline will run indefinitely. So to stop the pipeline, normally in Morpheus, you just push Control-C, or you call pipeline.stop. Or in this case, we're going to hit this interrupt kernel up at the top. So just wanted to mention that. Don't be surprised if it doesn't complete. So we'll wait to see that the pipeline is up and running. And now we need to trigger the microservice. And so we can't do that in Python because it's currently running. As you see, the busy is down here. This means that the kernel is running. So we're going to just copy this curl command. I'm going to open up my my terminal window and make sure I can see the actual output, which should be right here. And then, whoops, I'm going to paste it. I will hit enter. And so you see, the second I hit enter, we get this got request, which was the exact, this is what we're displaying. So you can see that what I send over here is just printed over here. It's going to then run the executor chain over and over and over again. And then it will finish the chain. And see, it hasn't exited. So if we rerun this over on the right-hand side, it'll trigger again. You can do this, get really happy with it, send a bunch all at the same time. Because of the way Morpheus is architected, it's going to, as the messages come in, it's just going to start processing them all at a time. It's not going to wait for the previous one to finish before it starts the next one. And over here, if we hit the stop command, it should, all the way at the bottom, it will print the output of, so I repeatedly sent this 6 times, and so now we can see that we got 6 outputs here just because it was keeping them all in memory. And just to kind of illustrate that we can tweak this pipeline. So say we don't want to see the output. So I can just remove that and then rerun the pipeline. And now when I send this, we're not going to see that got request message. So it's just going to start jumping right into the agent executor chain. And that's how easy it is to tweak these pipelines. You can just change what stages you add to it. So that is the end of the notebook. The notebooks will be available for about, I think it's 4.5 hours, just to cover the time. And I think you can spawn it up to 8 hours today if you ever want to revisit it. But after the 8 hours, they will be going away. But so I encourage you, if you want to play with it now, go ahead and do that. Our goal with this notebook is to eventually provide it as a DLI if you want to revisit it or show it to anyone else, that'll be coming. So with that, I'm going to hand it off to Joel from CrowdStrike to tell us some other really cool use cases about Morpheus and how they're integrating that into their platform. Sure.
What's two takeaways that somebody that's like a non-developer should take away from this interaction?
The takeaways we want to show you is what you can really do with LLMs that's not just chatbots, right? So we're actually using the generative AI to do kind of like higher order reasoning in an event-driven way where you are not triggering this like from, talk with your data. You can do some really cool things by chaining these models together, and the process that you need to get there requires a good amount of experimentation and understanding how the LLMs work, and then using the tools that are available to you to kind of execute on those. And then the last thing is just how Morpheus can help enable that by how easy you saw it was to go from a debugging pipeline to a microservice, and how easy it is to add a stage, and to only the small changes we had to make to go from a RAG pipeline to full CVE. Those are probably the two takeaways that I would say would be good to take. All right.
Thanks, Michael. While Joel's getting set up, right, I'm going to introduce Joel a little bit. Joel is Joel Spurlock, VP of Data Science at CrowdStrike. Joel's a ton of experience. He's going to tell you all about it. I'm not going to steal any of his thunder. To reiterate while he's plugging in what Michael said, one of the great things that I really like about Morpheus, about the SDK, about the framework, is you do have that kind of flexibility. You already have data flowing through these pipelines. You can add stages to it. You can bring online capability, and it scales out very, very well, right, as you kind of saw. The other thing is reusability, right, of those modules, of those stages, and the flexibility to program in Python, the flexibility to program in C++. Our goal with something like Morpheus is to make sure that you all don't have to be CUDA developers, you don't have to be HPC level type developers to grab that performance from Ampere, from Blackwell, right, when you have access to it. So definitely take the opportunity, a ton of resources online about Morpheus, but I think Joel's ready to go now. So Joel Spurlock, thank you.
Thank you. Honestly, I'm really happy to be able to be here and talk to you all today. As he said, my name is Joel Spurlock, Vice President of Data Science at CrowdStrike. We love data science at CrowdStrike. I've been in cybersecurity for about a little over 2 decades. And my area of expertise is the intersection of human and machine intelligence for cybersecurity outcomes. And I'm excited to talk to you guys about how to take a bunch of the technology that you guys have been walking through today, the Morpheus capabilities, and plug them in to Falcon for cybersecurity outcomes. So what I'm going to talk about here real quick, first of all, sort of set up why is this interesting and important, to put some knowledge into what kind of use cases, things you want to think about when why do we need AI in cybersecurity. We want to talk about sort of the data that you can get from Falcon, tie together the specific use cases. Then we're going to dive into practical implementation of the Morpheus platform with the CrowdStrike Falcon platform, and then talk about some additional use cases and stuff that we can work on. So first of all, we need to talk about why. Why is this important? The couple different things I want to call out. One, we're dealing with much more advanced attacks than we've ever dealt with before. Gone are the days of somebody just brings along a piece of malware and or defaces a website, or ad clickers, that kind of stuff. That's long in the past. Right now we're in a position where when an adversary is working in your environment, he looks like your administrator. He's using stealthy techniques, moving between cybersecurity domains makes it a lot harder for you to be able to track down and figure out who's there and kick them out and stop the breach. They target specific gaps in visibility. So if you're not running a security solution in your cloud, they're going to go to your cloud. If you're don't have excellent visibility and capability in your IoT, they're going to go there. If you're in a position where the devices that manage your meeting rooms don't have any security on them, that's an opportunity for an adversary to install a C2. So these are things that we want to think about, and it's a complex environment. You're running all across the space with hidden risks everywhere. Whether you're talking about software as a service, you're talking about supply chains, all the different API surfaces, these are all opportunities, they're attack surfaces available for an adversary. And we have to be in a position where we have visibility, where we have context, where we're ultimately able to spot the adversaries wherever they go, and then be in a position to resolve that. And it has to be fast. In terms of legacy technology, I talked about malware. Like today, 2023, 75% of the attacks are malware-free. So the adversary is getting into an environment and they're using creds. They are not in a position where they're just bringing along a payload. And so the way that we have to think about cybersecurity, is a little bit different. They're walking in with, vulnerabilities. So we just talked about the use case with CVEs and being able to optimize some of your workflows for finding vulnerable containers. Those are surfaces that adversaries could walk in at. The other thing we have to think about is operational inefficiency. All of this increased overhead, high rates of false positives, especially when we're thinking about ML and traditional detection technologies, there's a cost to cybersecurity, to a cost of visibility. How many SOC analysts does it take to run your security for your platform? And if you think about the cybersecurity skills gap, roughly 80% of organizations are reporting that they don't have the humans they need, the security experts they need to be able to, they can't hire them. And that's because, largely speaking, they don't exist. Generally, there we go. I don't know why I clicked through. Okay, so let's talk about just a couple statistics that are interesting here. First, when we're looking at the need of why we need AI-powered security. So an adversary can break out. The fastest time we've seen in 2023 was 2 minutes and 7 seconds, which is insane, by the way. Fun story, I was looking at a presentation in October of last year before these statistics were compiled, and the fastest breakout time that we had observed is 7 minutes. And so breakout is like how much time it takes for the adversary to, once they've engaged on their first device, to move to the next device. And when we're thinking about the cost of cybersecurity, when we're thinking about how much it takes to resolve an issue, like you have to go backwards from the point where you found the adversary and clean up all the things they touched. Every single time they touch a new surface, that increases your risk and increases your cost that they're going to get to their objective. And so, like, 7 minutes last October, and I'm just thinking about this. It's like, how many people can actually, at the point where an alert is presented to their SIM and a SOC analyst has actually got eyeballs on it and is trying to make a decision, how many of them can say they honestly have that pipeline working in less than 7 minutes? Raise your hands, right? And now we're at 2 minutes. So, this actually just doubled down, reinforces the need for, automation, for enabling capabilities like leveraging the Morpheus platform and other AI-powered security outcomes that can be highly effective in amplifying the capabilities of a security team. A couple other things that are interesting to note. There's some independent reporting. I believe this is Statista from 2023, but 204 days is the average time it takes an organization to find a breach in their environment. I think IBM had some reporting of 287 days. Like, this is a hard problem, and because adversaries are moving around and they're stealthy and they're trying to figure out how to bypass, you have to have technologies that can find those signals that are non-obvious. The other thing that's probably worthwhile is there's a very large number of tools that are required. It's a complex security stack. And in a complex security stack, because you're running everything from mobile to IoT to containers, all of that space, we're in a position where we need additional technology to help us manage all of that. So just a real quick background on CrowdStrike. We're kind of like the OGs of AI and cybersecurity. We started with a platform that the intent was ready-made for AI. So we've been a leader in AI native innovation, and not just AI in the marketing term where everybody goes and replaces ML with AI, and then we're actually talking neural networks and more than just your classic regression classifiers or things like that. It's the power of running it in the cloud. So this platform, we're pioneers in this space in EDR with our unique approach. Our cloud-native platform lets you run technologies that don't necessarily fit on the endpoint. This has enabled us to drive and collect basically the best data. We have industry-leading data on the security space, letting us understand and move to pioneering the first ML-powered technology for detection on VirusTotal. And there's a number of firsts all the way. I'm not going to read them all out, but the latest one I am particularly proud of is the Charlotte AI. So that's our generative AI solution that was released earlier this year. And all of it, generally reflects that we have really great data, and that data has enabled us, with our pool of experts and the support, the crowd in CrowdStrike, all of our partners and customers, to be an excellent platform for some of that AI native innovation and capabilities. Our ultimate goal here, and what I want to talk to you about today, is how do we democratize AI for our customers and partners, and how do we make it a tool that's really, instead of being useful for adversaries, it helps us as defenders. Enter CrowdStrike and NVIDIA, right? So we want to be in a position where we want to make a solution that's going to be more effective. And if you start with a platform that's ready-made for AI with really great data, that's highly tuned, high fidelity, targeted towards security use cases, and then you plug together NVIDIA, whose accelerated compute is virtually a requirement for any of today's AI technologies and workloads, and ultimately enabled by some of the Morpheus stuff that we talked about and you guys have all run through earlier today. It's like a match made in heaven. So I'm actually really excited to go through some of this stuff and talk through the specific details of the work that we did. So first, question here. Whoops. Yeah. Okay. How's CrowdStrike and NVIDIA advancing AI and cybersecurity? The marketing splash of hey, we're making it better. What does that actually mean? So the first thing we want to talk about is we want to empower our customers to build custom AI applications in our on top of CrowdStrike's data, and then powered, of course, by NVIDIA's technology. So this is very much a bring your own ML, democratize solution. So which is the next point. We want to accelerate AI across all of our partners and customers. So this is enabling defenders to use the technology and not only just touch security use cases in their environment, but also adjacent ones, whether it happens to be in IT, vulnerability management, which we've talked about, insider threats or so on. And then, of course, the last is innovate, right? So we want to move beyond the position where we're looking at all the status quo. We want to work together with NVIDIA to be able to deliver new AI-powered solutions that stop breaches. The vulnerable container assessments, one, of course. We can think about supply chain attack detection, cloud anomaly detection. So there's a bunch of different spaces where we can combine the power of CrowdStrike's data and expertise with NVIDIA's AI accelerated technology to ultimately get better outcomes. So let's talk a little bit about the mechanisms here. So I did mention the AI native Falcon platform. I talked about our rich data. We're not talking small amounts of data. This is a thing to think about when we're looking at costs. We're talking about, across our entire deployed base, trillions of events a day, petabytes daily. It's a lot of data. And so you need to, that data is all tuned for cybersecurity outcomes, whether it's data protection, whether it's, looking at traditional attacks via EDR, containers, and so on. And that, embedded into that is a cycle that allows us to use each and every one of you when you pull out a detection or a signal or identify something as a true positive, that feeds back into the system and makes it a little bit more intelligent. There's just to think about the scale and some of the opportunity, there's 250 million, give or take, API requests a day to the Falcon platform. And we're going to be using some of those APIs to help demonstrate the Morpheus solution. And there's more than 400 integrations. So Falcon is a platform, not just a security product, but it's actually a platform for enable all sorts of security use cases beyond the ones that are native to it. No, really, it's when we go and look at the Morpheus solution, then it's whoops. There we go. So then, of course, when we go and look at the Morpheus solution, we've now got the GPU and LLM acceleration. We're working at a way to consolidate, take that contextual data, pass it to Morpheus, get some inference functions run on whatever models that we think are interesting, and then pull that data back and use it for cybersecurity outcomes. Okay, so this is a view sort of the how you create that virtuous cycle, right? So in ML, and I think we talked about it earlier today, you have to start, you have to collect your data, you're gonna have to figure out how to train it, but then you have to move beyond, how do you use it in a real workflow, and then how do you evolve it? A big component of AI and ML technologies is how you tune it in operations. It's probably one of the hardest things that you have to think about when you're doing ML and AI technologies. Using it, right? Like there's a cost to that, and you have to make sure that you have experts tuning the data, doing retrains, understanding the accuracy of the system, and making sure that it's maintained so that it is a cost-effective solution overall. We're going to go through actually some of the individual components of that today. We're going to talk how to collect the data with the Falcon platform and pass it to the Morpheus pipeline. We're going to talk about how to train the model and how to use it for protection scenarios. We're going to have to imagine how to evolve it because we're not going to be running this in production for months, but it'll be interesting to talk about. Okay, so this is, I think we've touched on this a little bit earlier with the Morpheus pipeline, but like how do we bring the power of NVIDIA to Falcon? So this is essentially reiterating a lot of the points that were covered earlier. It's always good to reiterate when you're walking through stuff. With Morpheus, you have a rich capability. You can walk through, you guys built models this morning, you plugged them in, you built a microservice. Those are all the same skills that you're going to need. We're going to touch on each today as we go through the direct integrations. And in the case of our demo, we're going to be showing, so you see there it says custom security integrations with SIM and SOAR. So we're going to be showing the CrowdStrike elements of the CrowdStrike log scale and Falcon Fusion, which are part of our next-gen SIM and SOAR capabilities that are built into the platform. And we're going to do a custom security integration. So what that use case looks like, what we decided to focus on for our demo is intellectual property theft. On top of this, we used the digital fingerprinting. Doing some anomaly detection on top of the data that we were able to collect in Falcon, and then ultimately being able to push the result back into the platform and be able to see the result or see the anomalies that were identified. And intellectual property theft is interesting. It touches a bunch of cybersecurity use cases. One of course is insider threats, right? Like, so you're going to have somebody who's potentially, executing corporate espionage as a possibility. It could be the start of some sort of supply chain attack, even ransomware when you're doing network activity that's anomalous. And then one of the main features of ransomware threat actors is the extortion, right? So they get a threat on multiple layers. Not only do they hijack your data and encrypt it and prevent you from getting access, but if you don't pay up the ransom, they can release that information publicly. And then, of course, there's other layers of risk that you create by having that data exfiltrated. So what we're gonna touch on here, so beyond the digital fingerprinting, is we'll talk about some additional use cases. So what does that look like mechanically in setup? So the first thing we want to do is, on the left-hand side, I think some of you might have seen this slide earlier. It was in Bartley's presentation. But you have the Falcon platform. So that's running with high-fidelity data. It covers, anything that you can see, whether it's identity, container workloads, cloud endpoint, all the rich cybersecurity data goodness that goes in as an ingredient for building a model. And we're going to go ahead and plug that into the Morpheus training technology to train and build a model, and then ultimately be able to plug in an inference function on one of those container microservices that gets set up so that we can predict out the other end a result that's useful. One of the things that's interesting on the right-hand side when you think about pushing out that result, you can then view that result in the context of all of the other detection activity that's running. So all the behaviors, everything that led up to it, anything that might have occurred around it. And in cybersecurity, context is king. The difference between a PS exec that is a legitimate use case and a PS exec as the adversary is intent, because otherwise the command lines all look the same. So now we get to actual, demo pictures. Unfortunately, I don't have a Falcon SID for all of you guys to spin up and run this real time. But this is the Falcon Fusion user interface. This is part of the SOAR capability of the Falcon platform. This text is a little bit small here, but broadly speaking, what we're doing here is the data extraction. So on the left-hand, so you got 3 little boxes there. We're using Morpheus ingest to be able to export the data. There's a schedule function, so you can schedule to select the data, whether it's on demand or on an event. But ultimately, the goal here is we want to collect a bunch of information so that we can go do some training. Again, this is super simple to set up. So then, of course, you've got your action, which is the middle box there. That action is to search log scale, which is the data store backing our next-gen SIEM and observability platform, and identify. In this particular case, because we're doing intellectual property theft, we're looking actually for network data, which is the key signal that's interesting. And then we're going to basically, on the other end, do Morpheus ingest. And you basically just pop the URL in from your pipeline. It'll pass the data over, and then you can use it for training. What that looks like, and I apologize, you guys can't read this because this is a low resolution screen, but you can construct a query off of any of the data that exists in the Falcon platform for what you want to export. In this particular case, you'll see a better version of this in a second, but that's Network Connect IPv4 events associated with some containers that we're selecting here. And do apologize that it's hard to read, but we're looking for data leakage. And data leakage, when you think about the export of information, it moves around on the network, right? You're not gonna, unless you're walking in there with the USB key, right? There's gonna be some network activity. So it's a great place to focus. Now, in this, you can create any sort of query you want. It's highly flexible. You can tie it to other events. Maybe only trigger it off based on a detection that has already existed, so you can combine multiple signals together. It's a very rich search language that lets you look at all of the data that's in the platform and then figure out, what do I want to get for my prediction context? And this is ultimately going to be the information that feeds your model. Okay, Yeah, so you develop this query, the data will get exported like I showed you in the previous step. So now we look and I'm like, well, again, this is easier for me to see than you guys. But we're in a position of, we've got our data and we've plugged it into our training pipeline. And now we need to figure out, how to make something of it, right? So in data science, some of the most important things you're going to need to do is collect your, do some pre-processing, massaging, understand the quality of your data. Is it going to be useful to build a model? So when it comes to ML and AI, it's pretty much all about the features. Bad data, bad features is going to result in a terrible model. You're going to get a terrible outcome. If you have the incorrect priors, it's unrepresentative of the data that will ultimately be predicted on in a production context. All of these things can spoil a model, lead to bad results, and end up actually costing you more than if you have the good information. So you want a model that can, has features that can differentiate between classes. You want it to be trained on feature-rich data, which again is what we talked about in the platform. The other nice advantage of this, because we're pulling the data literally right out of Falcon, so if you're building a custom use case or model in your environment, it is literally going to match 100%. Like your corpus and the field data it's nice to be in that position because you're building a model on the real stuff. So again, in this case, what we're looking at is network events. Some quick analysis. So this was done on the query that you saw earlier. You see, fields here. We're looking at like what are the fields that we have an event. There's a whole bunch of them in here. What's the cardinality, the uniqueness. So this is what we're looking for is are these interesting features to be able to differentiate our classes and what we're doing prediction on. So IP address is nice, especially when you think about infrastructure. Applications, largely the deployed, you have fixed IP ranges for your container infrastructure. You've got services all talk to each other the way they're supposed to. That's an interesting notion. They create patterns that ultimately make for good anomaly detection when you deviate from those patterns. Again, also very similar. You see things like port and connection, and these are all functions of network, as well as things like context-based file name that highlights who's doing the work, right? Ultimately, this gives us clear signal that the event data we passed in is going to be good for our prediction purposes. So, yeah, bit of an eye chart here, but a couple things that we're doing on this slide that I want to talk you through. So we've got our model, so we've got our data. We've done some pre-processing. We've selected our features. We figured out what we want to build a model for. We've verified that our features are broadly going to be useful. Now let's do some of the data science components, right? Let's see if we're able to actually build a model. And so on the left-hand side of the screen, you have the training of the autoencoders. This is one of those key modeling steps, and we want to figure out if the system can learn. I can't quite. I mean, the numbers are small, but broadly speaking, that data suggests, hey, this information we're going to be able to learn on the model. So our first step was, do the features represent certain uniqueness? Now we've run our next modeling step. We've determined, can we actually, is the system presenting information that says, yeah, I can learn on this data, and on the right, what you see is the training that's run against those data sets, and those will be stored in MLflow. And as new models are trained, you can see these experiments all showing up in MLflow. I'll show you a screenshot of that in a sec. As most of you guys know, data science is a lot of experimentation. So you're not going to run the first model out and ship it and turn it in production and celebrate. Like it's there's a lot of work that's required to go through the experiments. Select your data, make sure that it's the right fields, make sure that it's got a good differentiation. That process, you'll probably be running through these steps and the two before it many, many times before you get an outcome that you're really satisfied with. Yeah?
Is the data's run, in this case, it would be the client's data that you build in the model, like your internal data you build in the model?
So this is actually, we're walking through sort of the bring your own ML. So if you were a CrowdStrike customer and you had, this would be your data. Yeah. We do things like this internally in CrowdStrike. Like, we do data science on our customers' data. We spend special effort to make sure that we've removed all the PII and all of that data, because it turns out that that teaches the model bad things. So we really want to be careful, not only to be compliant, but to make sure that we're building technologies that predict generally and work for everybody. So, but yes, this particular case, this is a bring your own ML. You guys are predicting on your own data, which is really important. When I talked about that sort of prior step, you want to predict on data that looks like your customer environment, right? Because then when the outliers show up, they're outliers for you, not outliers for some other organization. Do you have a question?
For that data, you mentioned network data, and that's massive for both customers and internal. How are you storing and then leveraging that?
So that's a very interesting question. I think we'll touch on that one at the end, but keep that one, because it is, when we talked about costs and predictions, so imagine you decided you want to plow all that through an LLM. If you wanted to build a query that consumed all of the network data that you're seeing in your environment, you would rapidly destroy your budget. So you have to be really careful when you're making those selections. Yeah?
So you are basically training this in the previously existing data set, right?
Yes.
What about detecting the threats, tracking online?
Oh, so you're jumping ahead. Let's just wait and see. So, yeah, so you're going to end up running these experiments a lot. What that looks like is, in the ML pipeline. So you see here ML flow. There's a bunch of experiments that we ran building out models. So in the digital fingerprinting, for example, there's a bunch of ways that you can approach that. You can build models on per infrastructure, per user. There's lots of ways to differentiate to ultimately get better outcomes. Per application is a great way to think about it. You can even touch on some UEBA use cases and tie this to user entities. But broadly speaking, when we talk about again, we showed this. You guys have seen all of this earlier today. This is part of a mature modeling pipeline. You need to be able to version your models. You need to be able to retrain them on a regular basis, and of course, being in a position to execute them for inference. So now we've got our model, and we want to figure out if it works, right? So we built a model, we collected our data, we checked, did our auto encoding, we know our features are useful, we did the modeling exercise. The output from that also demonstrates that it should be able to predict and get useful outcomes. And so now let's test it and see what it works, what it does. And so in this particular case, we did a spoke test. We injected some data that looks like a real attack. So we simulated an older vulnerable container that had some malicious code. It was operating on the network. An adversary, attempting to simulate them accessing and exfiltrating source code using that container as an access medium. In some sort of anomaly or outlier detection, you don't always detect exactly what you were looking for. So we started with a use case, or let's think about detecting our IP leakage, right? In this particular case, we injected the vulnerable container doing the access, and that sort of data leakage scenario could be intellectual property theft, right? As we started. It could be a supply chain attack. It could be also, again, like an insider threat or ransomware threat actor accessing data to exfiltrate it prior to encryption. So all these scenarios, the point is the model found something interesting, right? And it looks weird. And if you have something that looks weird in your environment in cybersecurity, you want to look at it, right? You want to bring that to the attention of your SOC analyst. And so here on the left-hand screen, we've got a bunch of snaps from Jupyter Notebook. You can see that a couple features called out that were really interesting for the purposes of the anomaly detection. So the left screenshot indicates the fields local IP and config build, which we're curious. And on the right, you can see this is like data science goodness. If you build a model that looks like this, you should be celebrating and jumping for joy. because here over on the right, covered in the red box, you've got the outlier. So when we injected the simulated attack, at the other end, the model was able to get a result that we could be, well, really happy with as data scientists. So now we got a model, built our model, we tested it, we know it works. Let's go ahead and plug it back into the system. So we go back into our Fusion platform. We have to, instead of pointing to the Morpheus pipeline for the training data and being able to build it up, now we're going to go to the microservice, right? So the step that we talked about 40 minutes ago, like how do I convert this thing that I built into a microservice container? I think it's a NIMS is what you guys are calling it now. But now you got to plug it in. So you can, again, start with your very simple SOAR integration via Falcon Fusion. You select the frequency. It could be on demand. It could be on a schedule. It could be on event. This is one of the things you want to think about when it comes to volume. Like, imagine you're doing a network style detector. Maybe you're only going to trigger this after a new container spins up that you haven't seen in a while. Or like, after every new container spins up, you look at those events. That's a way that you can kind of control volume and cost. The other way you can control volume as cost is your prediction function. So in terms of like what's your query that drives the ultimate data that you're going to export. This is actually a really simple representation of the SOAR implementation. This is a rich integration. You can plug in all sorts of stuff here. You can tie it to alerts, events, arbitrary searches, external triggers, whatever you like. So this is, again, for the purpose of demonstration, the idea is it's easy. And then, of course, we want to call the Morpheus ingest for that microservice that we created. So at the end, we plugged it all together. We got our model. We're running it in the field. We're getting our data. System throws an alert. And then, like we talked about context and how you take that one little signal from, from that network anomaly the model's able to identify for information leakage, for IP intellectual property theft. And we got to go, OK, what do we do with this, right? And now let's talk about that context that you can show back in the other end when you're operating in the Falcon platform based off of the result that Morpheus was able to emit. So in this particular case, you can see we've got the computer name, we've got the user, so it's identified who done it. That's really interesting, especially when you're in an attack. You could actually walk through any of the graphs or incident workbenches or other capability to like figure out additional behavior around this. This is a simulated report that, say, a SOC analyst would write up as a result of investigating that. So, it talks about it's accessing the intellectual property server. So that would be, something that's available via the asset graph capability in, like what is this server that's being connected with? And you can find that information out. You can make decisions about it. This is all context that ultimately informs a SOC so that they're making a better decision, right? And ultimately, you got to know the who and the where and the what and the why is a function of intelligence. Again, that's part of the Falcon platform, or you may have your own intelligence capabilities on top of that. Ultimately, this gives you the information you need to be able to start to make decisions, right? So we've connected this from the beginning where we found a use case, we created a model, we tested and make sure that it worked, we plugged it into the platform, we got a result out, and it gives a SOC team, a security operations team, what they need to ultimately make a decision. So pretty nice, right? Then beyond that, we can create dashboards. This is again a self-service system. So in a bring your own ML use case, anything you can come up with, like you put that data back in, you can build dashboards, and it's a pretty rich platform that enables us to pull up data and drive workflows. So, in an example of some of those, scenarios that we talked about earlier, like the vulnerable container or other activities, you can start to drive, user workflows or SOC workflows on top of the information that the system is able to provide. You can create measurements on it over time that ultimately allows you to operate a model beyond the beyond like, can I create a model? Like, how do you use it? How do you sustain it? How do you measure it? How do you understand when the precision is going down, so you need to retrain? Is it drift? What kind of decay rates are we seeing? Things like that. Ultimately, you can't produce this kind of data. You can't take this signal that's generated by the system and make use of it without that rich cybersecurity context. So this is, again, an opportunity. Bring your own ML, come up with the use cases, and then we can touch a lot on different aspects, different use cases to ultimately deliver an outcome that's really beneficial. So I want to talk just real briefly, like we started with the intellectual property theft. That's one possibility of many. Our goal here is to democratize ideation. We want you to walk out of this and go, there's a lot of opportunities here that I can dig in and start to explore modeling to improve my security outcomes or my security adjacent outcomes. So an example, insider threat. So imagine you have event data that's coming through the Falcon platform that's insider threats, it's rich security data, you need to drive that, and you can combine that with your internal HR data. And that may be a tool that you can use to influence your insider threat program. Or if you want to detect supply chain attacks, you can start to look at anomalies associated with software that you run. And that's an interesting, like, do I have a vendor that's at risk? Should I spend time looking at that? So you start to collect the data out of the Falcon platform, you tie that back with the internal knowledge in your organization that you're aware of, and ultimately you can get a better outcome. There's a bunch of different ways to think about this, like there's incident prioritization, there's container vulnerability management that was mentioned earlier. The sky's the limit, ultimately. So we don't want to be in a position where we're saying, well, you have to go implement it this way. This is an opportunity for experimentation. As I mentioned, data science is very much an experimentation effort that is necessary to yield the good outcomes. And we want you to go and take Morpheus and start to leverage some of that stuff. I believe the beyond Morpheus, this is all I got to do a plug for NIM. So you can turn all of these Morpheus microcontainers into NIMs that ultimately are able to use that. I believe that was announced earlier this week. So how do you get started? We got a nice URL, QR code for folks want to be able to, if you're not currently a shared customer, you can engage and get access to a trial and start to play with this. Otherwise, the Morpheus platform is available. As it's been referenced, it's open source. And you'll be able to plug in and start to experiment, ideate, and honestly, I'm really excited about this. Like, this is democratizing AI is something that I'm really passionate about.
Yeah, I'm wondering, so I recognize, like, at least my opinion is that you want to keep domain expertise. Right?
Yeah.
What type of conversations are you having where, maybe a client is thinking that, maybe we can categorize potential risk and we don't really need a domain expert here. We just need someone who can read and comprehend, these mitigation steps and then send it to the team. Send it to the relevant team. Do you see that taking place? I mean, I just see from
Yeah.
my perspective, you could sort of eliminate certain roles in certain categories of risk because maybe the tool is performing at such a...
Yeah, I mean, everybody's SOC security operations are different, like to start with. So every organization is a snowflake, which is why it's interesting to think about how do we enable some of this technology for so those bring your own ML scenarios, right? In all data science, you need to have some level of subject matter expertise for the purposes of building the models. So you've got your scientist, of course, who's your math wizard, right? And then you've got the folks that are able to translate the problem into a math problem. And you may be lucky enough to find a unicorn who's like all these things together. And then you have your users, whether they're subject matter experts that are dedicated to the problem or ultimately are consuming the output, and they need to create that sort of virtuous cycle feedback loop. So if I was imagining, a use case, if you've got a model that gets to an extremely high level of accuracy for the problem space that you're trying to apply it to, yeah, you might need less subject matter experts to operate because you've made your system more efficient. So if you think about like one of the things that AI does in cybersecurity is it specifically allows you to up-level or improve the operations and the performance. So when we're looking at I mentioned earlier, 80% of SOCs like literally can't hire the security experts they need, right? And so most of the people coming in are either really expensive or junior because they're just coming out of college and they don't have that rich experience that comes from doing security operations. And so with AI, generative AI, LLMs, you can start to up-level the capability of your security team either by giving them less to look at that has a higher probability of being a true positive, something of interest, or by assisting them to accelerate whatever outcome. So if you need to spend 10 minutes to process a signal as opposed to 30 minutes, that's time that you get back that you can invest in other areas of your security operations. I hope I answered your question. Yeah.
A lot of the data that you ingest into your models is the data that CrowdStrike collects, but some of it is like industry data, like vulnerabilities. We have pretty good data in the industry, but there are a bunch of other points of information that we don't have very good databases for, like Windows registry data, stuff like that. So I'm curious whether you have some interesting solutions for this problem.
Ultimately, so just for those of you who didn't hear, the question is around, where do you get your data sources? What if there's not a well-defined data source for something like say Windows registry? It depends on the use case. So some cases, like the example I gave around insider threat, the data is sitting in your own organization. If we're talking about threat data in general, there's a number of approaches that can be taken, either generative approaches, where you create or simulate data. You can collect data from key intelligence components. So say you have an intelligence feed that highlights the specific area that you want to do prediction on. Like imagine you have an intelligence feed that spins out CVEs that are likely to be leveraged for an attack, right? Like that signal you can then use in if you wanted to build a workflow around that work. In the case of registry, like for example, you could use a sandbox solution to generate a whole bunch of registry keys that are leveraged in an attack, or you could look at some of the CTI repositories. MITRE Center for Threat Informed Defense that we do a lot of work with, they have a repository of just piles and piles of collected open source intelligence that you can start to mine for information. So the data's out there, or you can generate it, or you can acquire it via purchase. It just depends on your use case. Yeah, go ahead.
So as our dependency on models increase, the ways adversaries can attack these ML models are also increasing. So I was wondering how you guys approach the entire adversarial AI concept and attacks on machine learning models itself.
Yeah, that's actually a really good question. I was waiting for something like that to come up. So it depends on the model, first of all, right? So you need to, in your classic, actually I'm going to point at, who's familiar with MITRE Atlas? No? So MITRE, we've actually worked with them on this, and And we consume this as well. So they like put together a list of a variety of attacks that you could execute against machine learning technologies. The classic one is like, you wear a T-shirt that's got a bunch of people and it fools all the facial recognition or the stop sign. Most of the AI and ML technologies are actually a little bit more mature, and those things don't work so well anymore. But the notion of an adversary is going to try and attack your technology, bypass it, is par for the course. And so each model, you're going to have different things you want to think about. So in the simplest example, there's a scenario like it's a regression classifier. So this is the classic. I've got a PE file, right? I think there was another cybersecurity vendor that I won't call out by name, but you could append a whole bunch of strings from legitimate binaries, and like the model just stopped detecting stuff. And that's bad, right? Like that's not a use case, because if the adversary can do that, they're like, hey, I just snuck behind your entire solution. So we pay a lot of attention to that. So we do technologies like transform and do those attacks ourselves. And for each of the models that we deliver, we measure adversarial resistance. There's the notion of AI red teaming that has been, I think that's a popular moniker. It's been presented at DEF CON a bunch of times. We do that kind of work as well. So we test different prompts and try and measure. There's also the notion of, when you develop or leverage AI SaaS, you have to recognize that, say you use an LLM agent, it has security permissions, who's it's acting on behalf of. And all the same principles that you apply if it's a human, still apply. Like principles of least privilege, being able to make sure that the solution doesn't have access to data that it shouldn't. And then, of course, like when we think about fine-tuning our models, especially like if you fine-tune an LLM and you don't have the right security controls about what data goes into it or protections, like it's possible to get it to regurgitate all sorts of information. And so we need to be really, really careful about how we do that as well. This is probably a much longer talk. That's maybe not appropriate for this, the few minutes that we got left here. But it is really, really important. We at CrowdStrike are vigilant on our models. But if you guys are bringing your own ML, you have to think about, where's my data sources? Are they secure? Am I operating on proper security privileges? Have I tested this use case to see whether or not it's easy to bypass? Those are all really important things to think about. In practice, it depends on the model. I hate to say that, but it depends is actually a thing. So we have some models that we retrain daily because the specific space that they're looking at requires that. We have some models we retrain once a year. And it really it depends on the use case. What's important as part of your ML ops as you're executing a model that you look at what the drift is, what is the model performing with the right level of accuracy. There's a tolerance level that's appropriate for the use case and for your business, whatever it happens to be. And you want to make sure that when that, the model stays within tolerances and you have signal that lets you know, oh, I need to retrain this. You should probably get some sort of good idea during the modeling process, what the nature of the technology is likely to produce. But ultimately, it depends on the use case. I think I got time for one more. Maybe two more.
Piggybacking off of that, with the storage of that data that you're using for retraining and all the data that's coming in, again, it just being absolutely massive, how are you all approaching that?
Well, how are we approaching that, or how do we recommend you approach it?
Well, if you're having people retrain their models using your systems.
Yeah. So there's a couple different ways to do that. In terms of, again, depends on the use case and the amount of data that you're looking at. For the bring your own ML use case, storage is cheap. So if you want to export the data out of the Falcon platform and toss it in an S3 bucket, and then you can use that to retrain and support some additional retraining, that's one way to do it. We build internally to CrowdStrike, systems that are designed to ensure we have accurate labels. We benefit from the crowd, so when a SOC analyst says this is a false positive or this is a true positive, and we have ML inference that's yielding that outcome, we collect all that information, we analyze it all, make sure that we've got high quality labels. So even if we're in the anomaly detection space or generative AI space, we have a good signal of, is the model doing what it's supposed to? That, of course, you have to store that information somewhere, right? But every organization's store is going to be bespoke. Log scale, again, we have SKUs that you can pay for retention as well, and that's again part of an opportunity, but depends on the use case.
So you don't typically let it persist, or do you let it persist for a long time in your environments?
Yeah, so it depends on the models. Some models we have to think about GDPR and privacy, and there's a whole host of things we have to make sure we do to ensure that we're compliant with all of the regulations. Now that being said, they're actually to our benefit, because for the most part, teaching the model about PII is a bad thing. But it results in bad outcomes, more specifically. But in the case of, say you were to do this as part of your organization, it's your organization's data. And so you have a lot more controls in terms of being able to retain and store that. One of the things that is important in data science is you want repeatability. So if you can't, when you build up a corpus of information that you want to be able to predict on, you want to be able to reproduce the model based on that data. So again, sidelining that is useful. Also, you need to think about there's value, depending on the use case, to build up your corpus over time. And in that particular case as well, you don't want to be in a position where you have to jettison all the data you used for the first model. These are kind of data science fundamentals, but they're really good questions to ask. I think I got time for one more. So in this particular case, for the demo we ran through here, you guys would host the compute. So you would be running the Morpheus pipeline, and you would be connecting. I think one of the screenshots it had this is on an external, yeah. So you would be running the compute. Yeah, yes, yeah. So for this specific example, that's the case. Yeah, that is a conversation for the future. Okay, one more and then I'm done. So the SOAR platform is live data. So you can schedule with Falcon Fusion. You can say, I want to run it on demand. You can say, I want to run it on event. But that trigger is off of real-time data. And so that allows you to put yourself in a position where you can run your predictions at whatever scale you need. So it could be that you want to run a model after a detection has been determined to be a true positive, and then you can trigger it at that cadence, right? You can run it at user scale. Its opportunities are really dependent on how you guys want to engage. Okay. Thank you very much for the opportunity to present to you guys today. I'm really excited about data science, and I hope you guys all are as well.
Okay, yeah, we'll be quick.
Gotta catch my flight.
Thanks all. So we don't want to keep you from lunch because obviously, but we have a couple wrap-up slides and reminders, and then we were going to give you the opportunity to do some Q&A with the three of us before Joel has to take his flight. So I just have one quick reminder. Later today, we have a DLI spearfishing course. We'll teach you how to build a production-ready application to help produce spearfishing. And that's with JB and Adiola. So come check that out later. Also built on top of the Morpheus platform. And then I wanted to plug, we have Getting Started with Morpheus. If you want to access any of our other DLIs, Launchpad access, 90-day free trials. We're an open source project, but we also offer enterprise support. And you can get started and find all this information at nvidia.com/Morpheus. And then lastly, there's a raffle. I'm not sure all the details about this, but there's a bonus daily raffle code if you use this QR code. I'm not sure what you'll get, but you can enter the raffle. So I'm going to leave this up for a second if anyone wants it. And then I want to welcome you guys back, I guess. Do you want chairs or just want to? Joel's got his backpack on, so we'll just hang out.
Feel free to come up and use the microphones if you have questions, or if we'll be here afterwards if you want more of a one-on-one.
Yeah.
I know I have a lot of questions, but I'm just curious. It's a relatively broad question, but I'm a lawyer, and I'm just curious what conversations or what frustrations have you experienced when working with lawyers around cybersecurity?
Might be a better
I don't know if I want to answer that one. No, it's honestly, it's domain expertise. There's we want to be really careful. We want to be compliant with the law. We want to make sure that everybody gets the outcomes and they do it in a way that minimizes risk. And law in some part is about being able to make sure that you've minimized your risk. So I'm not going to say this is the blanket answer, but the challenges is ultimately domain expertise. We're all working for the same thing. We all want good outcomes. And it's just making sure that we can do that within the regulations and laws.
Are any of the auditing services looking at things like PCI DSS and HIPAA, paying attention to what's going on here, and are they factoring this into the work they're doing around auditing applications and so on?
Do you have an answer for that?
I don't think we're the right people to answer that question.
I don't have a lot of experience with that.
Some lawyers with domain expertise. Like there's a guy right next to you. You should.
You should talk.
Yeah. Yeah. Ask him. But no, for sure. There is, there's applications and there's a lot we're working through with. If we're talking about data privacy, if we're talking about like GDPR and all of these types of things, it's a much more foundational, I think, question for LLMs, right? Like if this information is in your model, right? Like it's very difficult to take it out, right? That's not really possible. So how are you retraining? How are you able to do that? And that's why some of the things like the data ingest, the streaming embeddings and all of this, if we make the analogy to the space is so fluid right now, so different chunking strategies are coming out all the time, different embedding models are coming out all the time. There's a constant need to re-embed, re-chunk, like to get, for a different application. We see that being also possible for like, oh, I have privacy concerns with something. There was an accident. No one has ever published private keys on GitHub, I understand this. But if something does get into your model, right, like having the ability to take action quickly and not spending, weeks or months to be able to do that is something like longer out on the roadmap, but something we're cognizant of.
I understand the technology side of this CVE whole use case you described, but can you say some more about the business and organizational sides of it? return of investment, how you justified the project, whether you documented results about that, staffing, whether the data science team was the same as the cyber team, whether those are separate, how they work together, all those factors.
Sure. You can do the data science part, yeah.
Go for it. I feel like we're at a lucky spot because it's in our best interest to develop new use cases. And so we have the objective of building something cool so we can share with you all for justification. But we also internally, we don't want to waste our securities team time unless we're building something to help them. And so we tried to try to come up with some metrics along the way. Mostly, we can look at the time it takes for a single analyst to do something, and then we can measure it against Michael's ultimate pipeline of how long it takes to run the CV analyst tool. And then to get the buy-in, I think what works well is to do this prototyping that we described so that you can get people kind of invested in your tool. And then it has to be collaborative the whole time because you want your end users to dictate like what's missing and where you're gonna go. And essentially, if you're building a productivity tool for someone, you need to know exactly what their workflow is to begin with. And so I think we got a lot of buy-in because this was a huge pain point for our analysts. And especially as NVIDIA is scaling out, supporting more and more containers, we knew like in the future it's gonna be an even larger and larger problem. So we kind of set up from a business case, just the layout of the land and how much time it would save now and how much time we're projecting in the future with the scaling.
And I mean, you mentioned that like the first thing that you did was we started with just the checklist and like, is this valuable? And bringing that back to the people who would be using it. And they're like, yes, it's great, but it'd be even better if it did X, Y, and Z. And that's how we ended up with one model, became a bunch of agents, became 2 more models after that, because we need a system for being able to evaluate and actually get that feedback loop to incorporate their data and actually make the tool better long term. So I'd say that, making it actually viable and getting the ROI on this requires, quick prototyping and then incorporating that feedback from the end users who are going to use it so that it's actually a tool that they want, and constantly measuring and understanding like how much value is this bringing, and then you can look at the cost of what it's actually costing to run on an OpenAI or NIM, and then make that final decision. I think that a lot of what we've also seen just from the business side is being able to integrate it with the right tools. If it's a hard to use tool and it's not in a place that they can even find, they're not going to use it. So one of the first things we did was we integrated this with our own internal system that's doing these scans, and then we feed it back into the system so that they can see the original report side by side with the Agent Morpheus output. And if it's right there side by side, they're using it every day, and they're getting that. It's like easier to use it than not use it type of a thing. So.
I just remembered there's also a legal stick that applies here because the VEX documentation and justifications are actually going to be to have your software run on an FDA device is going to require these VEX documents in the future. And so we actually use the lawyers as a good reason to say that we need to scale this out and be ready for the future where the VEX justifications are going to be ubiquitous.
Are you guys open to academia research? Because I couldn't get a login to your system. I was denied.
Which system?
A free access, a 90-day subscription to Morpheus SDK and things like. I couldn't get in because I was an academic.
We do. I feel like I'm yelling at you right here. We do support and have a lot of collaborations with academia. I don't entirely know why. Let me get your information afterwards, and we'll do it. My guess is there's a problem on the back end. But yeah, you should be able to get the 90-day evaluation to NVIDIA Enterprise and that all kind of stuff. Shouldn't be a problem.
All right. If there's no other questions, thank you for your time. I hope this was very valuable. We will be here if you want to do some more one-on-one questions. I think Joel's got to catch a plane, but
I got a little bit, but not that long.
But thank you for joining us today, and hope to see you at the later DLI this afternoon. And we will be at the booth if you want to come try a little more hands-on with the more advanced version of this that has the additional fine-tuned trained models. All right.
Thank you. Thanks.
Never known, will they love you when you're famous, where you never be alone? Hope someday I'll find nirvana. I'll be looking down below. I'll be dead at 27, only 9 more years to go. I got a bully in my head, fake love, fake friends. I was broken when you left, now you hear me everywhere you go. La-di-dee, oh la-di-da, wanna be a superstar, be the girl you used to know, playing on the radio. La-di-dee, oh la-di-da, loving me is suicide. I'm a dreamer, I'm on fire. La-di-dee, run for your life.
I'm gonna be a rock star, yeah. Told her I don't wanna war, yeah. I don't see me going far, yeah. That's what happens when I fall apart. All of me wants all of you, but I'm far away and I can't choose. Got a lot of lessons that I need to learn. Got a lot of lessons. My depression and misconceptions and all the mistakes that lead to lessons. My depression, it makes me question. My depression, it makes me question.
La-di-dee, oh la-di-da, gonna be a superstar, be the girl you used to know, playing on the radio. La-di-dee, oh la-di-da, loving me is suicide. I'm a dreamer, I'm on fire. La-di-dee, run for your life. California, where the angels cry for me. Want the drugs that taste like candy and blood diamonds in my tea.